Well, hello and welcome to SkyTour LiveStream for tonight, the 10th of December 2020. On your startup screen, you can see our logo on the left and you can see our logo on the right. But a fanciful version created, as you see down at the bottom, original artwork by Tara Deulis. She is a Phoenix-based artist who created the artwork for the door of the observatory out west in the desert. And I just wanted to show that. That's kind of cool. That's the Orion Nebula. But then again, so is this. This is the Orion Nebula. We just took this picture a moment ago. This is actually quite a short exposure. It's meant to actually show the interior of the nebula here. You can see this modeling in here. And Daryl hasn't even seen this yet. I don't think you saw this. In fact, Daryl's here. Hello, Daryl. If you unmute, Daryl?
Yeah, not anymore. I'm not. Okay. Hello, Mark. Hello, everybody.
Yeah, so Daryl decided to join us tonight. I set out an invitation to Amanda, but I think she's busy with Chris DiPerno's show on KGRA tonight, which is going to be the Eye Detective show, starring Chris DiPerno and Marianne Robb. Marianne actually had quite a day today. We talked earlier today, and she actually had a tough police day, chasing down perps and taking them into custody. It was actually kind of like cops on TV. It was a really interesting day for her, apparently. And so she might not make the Chris DiPerno show tonight that she's supposed to do with him. So we'll see.
She didn't, in fact. They said she was too busy arresting somebody.
Yeah, she was, in fact. Yeah. So I want to say hi to, of course, you, Daryl, and Cypher2 and Renee Cruz. Hey there, welcome. Renee was the first one. Well done. We have Q, and I won't tell you to get off my ship, Q. I won't tell you that. Welcome. This is great to have you here with us. And Gaia Savelis, how are you? James Dugan from Down Under, how are you? Gina Leone's with us. And it's the beginning of the night with Daisy and Zoe Amethyst. Hi, guys. So nice to see you. And our PG is with us tonight. Hey, welcome. This is the Orion Nebula that we're looking at right now. This is a short exposure, but we're going to just do a longer exposure here momentarily. So let's go do that. Now, if you want to see, for those of you that may or may not have been here before, just do a real quick rundown. Over here is the telescope control. This is the far left, upper left. That's right above me here. Okay, and this is me right down here. Hello, hi. Okay, Daryl's not here, but he's threatening to put himself here eventually. And then over here on the right side, this is the camera control section over here. And this is the observatory view, which we can actually zoom in and out of. And it's actually a pan and tilt system. We can actually turn the camera any which way in that dome to check out what's going on with the camera at any time. It's fully remote, meaning that I don't have to be there to run it. I'm doing that from here. And Carol Carl is here. Hello, Carol. And when you look at the center of the screen, that's the live view. We can do the live view with the straight view from the camera, but we can also do this, where we actually turn on video and we increase our sensitivity, and now you can see the live view of the Orion Nebula through the eyepiece. Isn't that great? So that tells us a little bit about where we are. This helps me in doing placements sometimes. Then we turn that off, and it looks like it goes away, but it's really there. It's just not as bright because the sensor is not being taxed at that point. So to make a still image of the Orion Nebula, let's say 20 seconds at 12,800 ISO. If you look here, this is the speed of the sensor, basically. This is the sensitivity of the sensor. And then this is the exposure time. So we're going to go 20 seconds exposing for an ISO, a sensitivity of 10,000. So that's pretty cool. So now let's actually take that shot. So 20 seconds on the Orion Nebula. I've been playing with things. I told Daryl a funny story. I was playing with the equipment earlier because I had a really strange artifact in there and I couldn't understand what it was. And I, for life me, couldn't figure it out. So I changed filters. It was still there. Whoa, what was this now? Is this something in the telescope? This is really bad if it is. Okay, this is another shot of the Orion Nebula. That's really pretty, except it's slightly elongated. It actually has a little bit of a problem. You can see if we come look at these stars over here. Okay, if we take a look at the stars, okay, you can see that the stars are just a little bit elongated, and that's not good. We want those to be round. Okay, so we're going to take another picture in a second here to fix that. This modeling you see, this is the noise. Okay, that's the noise you see from the chip, the camera sensor. Okay, so let's do that again. So I couldn't understand what this artifact was, and to see what it is, I actually saved some shots to show you. Okay, so here's a picture I took, and do you see that dark ring? I had no idea what that was. It was dead center in the view. That's dead center in the view. Now, to display it over the web here, like I was doing. Oh, that's much beautiful. Oh, look at that. That's really pretty. Orion's getting higher in the sky, so it's looking good. Oh yeah. So it was dead center in the view, and I didn't know what it was. So I was like, okay, I changed filters, so it's still there. It's not something on the filter. So that means it's either in the optical assembly of the telescope itself or in the camera. Okay, that's how I looked at it. So I took a camera cleaning brush and I went out to the telescope and I took the camera off the telescope and I looked at the sensor of the camera and it's perfectly clean. And I'm thinking dreadfully now, oh gosh, no, it's something inside the telescope, which makes it a terrible thought, a horrible idea. I hope there's nothing bad inside the telescope now. Now what am I going to do? Because I'm about to pack this up and send it out west. Oh, so I was really getting concerned. And as it turns out, I looked back into the hole where the camera just came out of, and ahead of the filter, which rolls, the filters roll through that space, but there's a round barrel between the camera and where the filters roll through. And in that round hole was a little tiny, wonderful, amazing spider spinning a web at 35 degrees in the dome. I was amazed. And I thought, this little guy deserves to live. He is really trying hard. So what I did was I carefully removed him from that barrel, and I brought him over to a part of the observatory that was shielded from the wind, where he could at least have a chance to survive. I don't know how well he'll survive, but wasn't that cool? And so I took photos, and of course, as you can see, the photos are no longer plagued by this little donut in the middle of an out-of-focus spider in the optical path. So that was pretty cool. I just feel bad for the little spider. It's like, man, the planet is not good to little creatures sometimes, it's really not. And that's an example of why it's not, because it's terrible. So anyway, I just
makes me wonder how he ever got in there.
I don't know how he got in there, because I'm drinking some pomegranate seltzer. I don't know how he got in there. That's really, really good question. It's a really good question. I don't know how he got in there. By the way, I wanted to mention Carol Carl, who's here. She is the host of Behind the Obsidian Curtain, Friday nights at 7 p.m. on KGRARadio.com. KGRA Radio has approximately 3 to 4 million people that it reaches a month. And Daryl and I and Amanda have a show called SkyTour Radio, Sunday nights from 8 to 10 p.m. on that radio station, which is KGRARadio.com. And we have that's SkyTour Radio, and this is SkyTour LiveStream. So this is a companion stream to the radio show. The radio show is about astronomy, and we often talk about the search for extraterrestrial life, because I am an astronomer. That's what I got my degree in. This is what we look like, And what we do is we pick a specialty, and my specialty is planets around other stars and the abodes of potential extraterrestrial life in our solar system and in and amongst the stars. And that's something that's really cool. I think it's just an amazing field, because you can look at something like this, the Orion Nebula. All right, this is a beautiful gas cloud. It looks stunning. It looks beautiful. It looks amazing. Yet if you were there, your very skin would be seared right off your flesh, or seared right off your bones, okay? Because this is a very, very hot, very active location. And if we take a very short exposure, which I'll do right now just to show you, let's just do, let's say 4 seconds. Okay, 4 seconds, but we're doing it at 10,000 ISO. You can't really tell that, okay? It's right there, okay? And of course, it looks like we're out of focus a little bit. All right, that does happen from time to time. In 4 seconds, we may not get just the right seeing, and so things get bloated a little bit. Orion is rising, so it's getting higher in the sky. Okay, that's a little bit better. But those 4 stars that you can see right there, and they're going to be a little bit hard to see right now because it is still low in the sky. Those 4 stars right there, those are called the trapezium because they look somewhat like a trapezoid. And those 4 stars are responsible for causing this nebula to glow, especially in this region about here. But you can't see their influence over here because if we look at a deeper shot from earlier, okay, you can't see their influence in here because this is all dark dust that you cannot see through. All right, this nebula here and this nebula are connected. Okay, they're all one nebula, and it may extend even further, but we might not be able to see it because this is a dark tongue of material that's overlaying the bright nebula behind it. And you can see that now. You can see that three-dimensionality now that I've said that, I bet. You can see how that kind of just reaches over the top, just like this reaches over the top. And Daryl has a funny way of helping you remember these parts of the Orion Nebula. And I'm going to let him tell you. Sorry to put you on the spot, Daryl, but I want you to tell them about the Baby Ruth.
When I look at the Orion Nebula, I see Bill Murray eating a Baby Ruth bar, like in the movie Caddyshack. If you see that dark bay there, that's called the bay, or some they used to call it the fish's mouth. That is a Baby Ruth, and just below it is his lower lip and his jaw. Just above it is his nose, and a little bit to the upper right of the nose is his eye. Those 2 stars there in that little dark patch.
Right here?
Yeah. And anyway, just, I see a face with, let's say, a Baby Ruth in his mouth, because that's nicer than the alternative. I will say too, though, if you look around on YouTube, not now, of course, later.
Uh-huh.
Uh, it may be NASA, it may be APOD, I forget, but somebody did an excellent video of a three-dimensional fly through of the Orion Nebula. It's really cool. It's really something to see.
Yep. Yep. And if you want to do that for free and have it at any time, then I encourage you to get the application or game, whatever you want to call it, called Space Engine. There's a free version, there's a pay version, and I did get the pay version because it has better renderings of nebulae, but it uses whatever three-dimensional data is available, and it has almost every galaxy in the known universe in it. And you can travel to all these different galaxies. Now, you won't be able to, once you do that, of course, the individual stars in the other galaxies are just hypothetical, but the ones in our galaxy are partly hypothetical, partly real. And there's a lot that are real, and you can actually fly to nebulae that we know and have seen and circle around them and see what they look like in a sort of a three-dimensional manner. And it is really interesting how some of these nebulae are represented just the way that astronomy thinks they look, and some aren't. Some are just a little too, what they call notional, not quite real, but they really do look cool. They really do look cool, and I would recommend you check it out. And so that's Space Engine. You can, I think it's like $25 on Steam if you want to buy it on Steam, but you can also download the free version. There's a free version as well. And I've used Space Engine for a long time. You can go to the planets, you can cruise along the tops of the craters of the moon, you can spin around. Oh, it just has everything. And if you do it, I think I don't know if tonight is a good idea for me to try that because it's a beautiful clear night. But there will be a Space Engine cloudy night stream that we'll do, and we'll take a tour of the solar system and beyond. You can go through Saturn's rings. You can go between Pluto's moon, Charon, and Pluto, and look back and watch the two of them going into the distance. It's just beautiful. You can relive the path that the New Horizons probe took as it went by Pluto. Really, really cool stuff. Really cool stuff. So, there you go. And the Orion Nebula here is actually quite an interesting location, by the way, because think of it as a blister on the surface of a dark molecular cloud, and that's what is all around it and well outside the confines of the image. And it's part of the I guess you call it the OMC, or the Orion Molecular Cloud Complex, OMCC. And that's what this is all part of. And when we say molecular clouds, we mean the things that are this dark dust, okay? Now, out in here, there's other molecules, especially where the temperature starts to cool off a little bit. Because the temperature in here, in this area, is so hot that the atoms of hydrogen gas and oxygen gas and other elements that are in there are ionized. That is to say, there's so much energy is absorbed by these atoms that their electrons jump off the atom. And when they jump back in, they're giving off energy in order to get back into the atom. And when they do that, there's characteristic colors that they are emanating. And one of those colors is red. That's a famous hydrogen alpha line that we talk about. H2, H Roman numeral 2, right? It's something that Daryl's familiar with, I'm familiar with. And then these greener areas here, these are areas that are where there's oxygen 3, okay, which is doubly ionized oxygen, right? Hey there, Tara. And so those are also regions that are just incredible, And by the way, since Tara just joined us, I do have to show you, Tara, this was our startup screen tonight, just so people can see, and you can see. Notice down here it says original artwork by Tara Duelis. Okay, just so you know. All right. So, going back to what we were saying, the Orion Nebula then is what we call a stellar nursery. And the stellar nursery is a location where many stars are being born. And we know that. We can see in here locations where stars are being born. And, okay, well, they don't show up typically as they don't show up typically in the okay, hold on a second. I have to reconnect with the observatory. For some reason it went down, but it's still there. Everything's still going. I just have to reconnect. So anyway, I was saying that the you don't really see what happens in the nebula, because to see the stars being formed, you actually have to see them in a different light. You have to look in the infrared, because that's what we have. That's where we'll see that happening. We don't see it happening elsewhere. In the visible light, we don't see it. All right, we only see it in the infrared, and so the infrared is what we look in, and that's where we actually can see it very clearly. All right, let's bring the observatory back. Here we go. So all that said, when we look at things like this, we're always seeing in the light that our eyes can see. We can't look at the infrared like we'd like to see, because unfortunately for telescopes to see in the infrared, they really need to be way, way up out of the atmosphere or on very high mountaintops. And for SkyTour East, we're at 250 meters above sea level. SkyTour West, however, is going to be well, 3 times that. So we're actually going to be higher in altitude, but we still won't be able to see infrared. All right, we will be able to see some, but nothing like you see from space and from the Lake Mauna Kea in Hawaii, which is at 13,000 feet. All right. So that said, I think that's pretty much it for the Orion Nebula tonight. What I wanted to do was to take another short exposure here to see if we can grab the trapezium to give you an idea a little bit more what's going on there. So this is 3.2 seconds at 6,400. All right, so that should be about now. There we go. Now check that out. All right, so now you can see what's going on in here, right? In the center of that nebula are those 4 hot young stars. They're not very old at all right? And you can see how they have caused a lot of ionization, that is, and a lot of gas out here to glow. And that's happening throughout the nebula. We just don't see the rest of it because we didn't take a long exposure here. But that's the central part of the Orion Nebula, you know, and it's amazing to think that there's this much more like this, you know, and there's even more than this. And when we do the wider field, you'll see, well, we can't do the wider field tonight, but in Arizona, we're going to have 2 telescopes active at any one time. We're going to have this one. We're going to have a wide field system also available at the same time. And that's going to be on another pier, another system. And we're going to be able to look at the wide field sky and do a comparison with the close-up sky with the large telescope. So we're definitely moving toward a new era, okay? And we'll be able to see even more detail in here. But for now, there's one other little guy I think that's kind of cool to see. And what we'll do, and this is the last part of the interface for you guys to see who haven't been here before. This is our interactive planetarium. It's also the thing that controls the telescope. And I shall just get rid of our observatory view for now. And so we are here looking at the Orion Nebula, and this is Orion here. How do you know? Well, we can add the constellation lines, and you can see that, or we can actually show you the mythology. There is Orion right there, okay, and he is right next to Monoceros, which is the unicorn, and down below him is the Canis Major, which is the hunting dog of Orion, and it's Sirius, okay, and then above Monoceros here we have Procyon, which is the little hunting dog of Orion. Okay, so that's how we tell what's going on here. And so this is an area that has so many wonderful things, and let's take a look now This is something called the Running Man Nebula, but we don't have to tell a telescope to go there. We can actually just move there because it's just above this. So if we move up, all right, we'll see some stars show up. Ta-da! And this is, I think, isn't this one of your favorites, Daryl? You might be muted. You are muted. Yep, he's muted.
Sorry. Yeah, I like it. It's one of your favorites, I know.
Yeah.
I like it too. Mark, can I ask a favor?
Yeah.
On your Skype page, you have a text box over on the right, large list of text. It's somewhat obscuring the chat. Could you scoot that over just a bit?
Yeah, I can just do that.
Okay, thank you.
Yeah, that's actually not a text box. That's the music list, and I can... Yeah. Thanks for letting me know.
No worries.
I dumped it. I got rid of it. Okay. So now, this is the Running Man. Now, this is what you see with your eye with a very small telescope. Okay? But if you were to look at this with this telescope, okay, let's just do 15 seconds here. At 40,000, this is really, really, this is really blowing it out. This is, it can handle much less than this. You'll see. But I just want to show it to you real quick. And there you see, okay, what's really hiding there in the background is this really interesting blue nebula. This is the Running Man. And the Running Man is really interesting to look at. But you might say, well, I don't see a man. I don't see a running man. You may not, but you know what? Let's take another picture and make sure you focus on this central portion. I won't move the telescope, so that's going to come back just as it should. So I'm going to bring this up to a 30-second shot. And now let's take a look at what it looks like. It should look a little bit different. It should look a little bit different to you. All right, so... And I want to say hello to and I want to say hello to Don Walker. How are you guys doing? Welcome. Nice to see you. If anybody has any questions, let me know, and I or Daryl can answer them for you. And then now let's see what 30 seconds gets us for the Running Man here. Okay. Now, this is a little bit brighter because we're going at a longer exposure, but you can see this shape better in here. Now what I'm going to do is go back again, and this time, and this will show you something a little bit more here about what we got going on here. If we look down here, this is our telescope control system, right? This is the directional control. This is the telescope's computer. This is the focus. And then we have this wheel. What is this? This is our filter wheel. It's a wheel that has 5 filters in it, and I'm just rolling it through now to a filter that's called Narrowband 1. Narrowband 1 and Narrowband 2 are different from each other. If we keep going to the next one, you'll see many stars. This is a complete hole. It's an open hole through into the telescope all the way out to space, right? And it basically shows all the light without anything taken out of it. So why wouldn't we use this? Well, we wouldn't use this because this also shows us the bright sky. It also shows us if there's light pollution. What we have in here are filters that actually take that out. And one of the filters that we use that's really, really good at that is one that we have here called Narrowband 1. Narrowband 1 is like, if this is the whole spectrum, if you look at me down the lower left here, this is the spectrum, right? Then this is what that pass-through filter looks like. It shows us everything, including all the light pollution that might be in here. But what Narrowband 1 and 2 do is take narrow slots out of that spectrum and show us only those narrow slots, because those are places that we know information is that we want to see. Narrowband 2 is slightly wider of a narrowband pass through those slots, and Narrowband 1 is really narrow. Really narrow. And so we're going to take a really narrow shot looking through this location, all right? And we're going to do it. And because it's so much less light coming through, but light we want to see, I crank up the ISO a little bit. That is the sensitivity over here. So I'm doing 51,200, and we're looking at this nebula here. And you'll see that you're gonna be able to visualize things better in the nebula, I hope. Orion is still low, as I said. You'll notice this little thing down here. That's not an artifact in the telescope. That's actually a dark dust cloud in this nebula. So let's see what we get now when we do this. I'm really excited. Oh, man. Hey there, Alex Bronze. How are you? Wow, look at that. Okay, so this is another shot, and let me just get rid of some of the noise. Do an instant noise reduction here. You'll see that the blue, all right, is also punctuated by some of the red. Okay, and if I take an even longer shot, then we'd see more detail. All right, but right now I don't think that's necessary because I want to show you stuff. All right, now we're at narrowband 2, so now we're slightly wider narrow slices through the overall spectrum, looking at the things that we want to see. Yeah. Okay, and thanks for answering Alex's question there, Daryl.
No problem.
All right, let's go ahead.
Huh?
What were you gonna say? You were gonna say something, I thought.
No, I just said no problem.
Okay. Okay, so now we're in this area. This is an amazing location. Now, let's go up to Alnitak. All right. Now, I noticed as I've been going through the database here looking for things, I've noticed that there are errors with the database, and we'll find out if Alnitak is known to the database. It's not my database, so I can't speak to the accuracy of the database. But let's make sure. So the telescope goes hunting for a star, all right, and then it lines it up, and then it moves to the object we want to see, all right, and I'm not sure that's Alnitak. Yeah, see, there's also another problem, that is the telescope guide system, sometimes because it's a telescope and then there's another telescope on top of it, kind of like in an angle like that, and that upper telescope is critical to the process, and sometimes that gets blocked by the dome. Kind of a bad design. I wish it wasn't like that. And I know that we're not in the right spot here. So what I will do is I will do it another way. Let me get us back to the Running Man Nebula. The dome may have to be moved too. That's the other problem. And that is a problematic system. Okay, so it finds a star that it knows and it centers it up, and then from there it goes to the thing it knows. Okay, so here it goes. Bring it toward the center, and then it's gonna do some fine centering, and then boom, it goes off to the Running Man Nebula. So
it would be funny if it's centered on Alnitak.
No, it wouldn't. Okay, well, there's the Running Man Nebula again. And now that we're here, it should just stop once it aligns.
Hey, Amanda's here.
Amanda? Hey.
Yeah.
I didn't see. I invited her, but I didn't know that she could make it.
I did too.
Hey, Amanda. Let us know if you want to come in, because you are one of the 3 hosts of SkyTour LiveStream. I don't know if she's just stopping by or if she can actually join us. And so this is the Running Man Nebula again. So what I'm going to do now is I'm going to bring us up. Okay, and that's what I'm going to do right now. And we're going to increase the speed at which we're moving. Okay.
Amanda says she'd like to join us.
Good. Okay, she'll be on momentarily. Amanda, are you here?
Hello.
Hi, Amanda.
Hi. Hi, everyone.
Hi, Amanda.
Hi, Daryl. How are you? How is
I'm
everybody?
good. You?
Good. I'm well, thanks.
Good.
That's good.
Beautiful night for a sky watch.
I know, it is. It's a beautiful night.
Hope everyone out there is well.
Yeah, it seems like everybody's doing fine. I
See,
haven't heard
35
anything.
watching. Welcome to all.
Yeah, I haven't heard any complaints yet. Of course, there might be complaints. People might not like what we're doing. Why are we watching all these little stars?
Mark,
The
could you put
stars tell
chat?
a story.
Oh, sorry.
Yeah, oh, that's fine. Sorry.
No, it's okay.
I have to look at chat than my ugly mug.
I'm sorry, what'd you say, Amanda?
The stars tell a story.
They do. They
He
do.
said people might not like this. Why would we look at little stars, little dots? Never
Yeah.
mind. Don't worry about it.
No, it's okay. I'm just trying to, get this to... I'm getting lost in Orion. But man, it's beautiful. Yeah, so I just have to come back here. Oh, that's why. Maybe I could do this.
It's supposed to snow here, Tara. We've had a beautiful run of clear weather, but it finally went away this morning, and they were saying rain, which I don't think it ever did, but then snow later tonight and maybe all the way through Saturday night.
Yeah, it was actually raining in Arizona. So I'll be curious to see if we got any water in the building out there. Which I don't know that we would, but you never know. Okay.
You're going to put skirts on the roof, aren't you?
Around the outside, primarily for dust.
Oh, yeah, but I would hopefully it would stop rain also.
Yeah, because we have a real heavy rain would get in the dome. In the dome, but in the building, because there's a gap of about like 2.5 inches at the ends where the roof rolls off and connects, and that's problematic. That'd be problematic.
Oh, yeah.
Yeah. Okay, so let's see now. All right, I'm going to try this object here.
Still won't lock on Alnitak?
Yeah, it won't. So I got to try something different and work my way down.
Huh.
And I don't know why it does that. Sometimes it's crazy. It does things that I just don't expect. Okay.
Sorry I left your show tonight, Amanda. It was time to make dinner, plus I was getting angry. didn't want to rain on anybody's parade.
No worries. Thank you for dropping by. There were a lot of pictures, so I wasn't able to be as active in chat as I normally like to be, as everybody knows.
Sure.
That's iDetective, for those of you interested. It's on KGRA Thursday nights at 6 p.m. Eastern.
Mm-hmm. No, the
Show.
Marianne couldn't make it tonight?
Do you know why Marianne couldn't join us tonight?
Oh, yeah. I talked to her for about half hour today so far, and she was she was doing what police do. She was hunting down and capturing criminals tonight.
Well, yeah, iDetective, obviously, is a show about cops, for cops, by cops. There are four former and current police officers host the show with a different guest each week. And our good friend Marianne Robb, who's helped Mark so much with SkyTour West.
Yep.
She's one of the regular co-hosts, but she was currently making an arrest. So she wasn't able to join us at the time of when we went on air, but good for her. Congratulations, Marianne. Stay safe out there. We love you.
Yeah, she's probably listening. She said she'd listen, but she couldn't really participate, so she's going to listen.
Now, for those of you that don't know, she's one of the good ones, so
Oh, yeah.
be sure to say hello if she drops by, Marianne Robb.
Yeah. She's a copper. She's
Very,
Good cop.
very politically incorrect show, too.
It is?
It is.
In what way?
Is that a good thing or a bad thing?
Oh, that's a good thing, in my opinion.
Okay.
What was she? What was?
I know
politically
you
incorrect?
commented our host was going to get in trouble with his superiors. He doesn't have superiors. He works on his own. He does his own.
Oh,
Yeah, so.
his shirt said Minneapolis Police Department. I was afraid he might get in trouble.
Oh, you're talking about the guest or the host?
The guest,
Oh, okay.
Stu Peters.
Okay.
Sorry for that digression.
No, it's okay. You can talk about the show if you want. I'm thinking that
There's another great show on KGRA. It airs Sunday nights.
I know.
8 p.m. Eastern.
I know that one. Yeah. I think I heard of that. She's talking about SkyTour Radio.
SkyTour Radio, yes.
8 to 10.
Our
Yeah.
companion show to this site, actually.
Yep. I'm going to run out to the dome because I am going to make sure that it's clear because it's not finding things, and I do believe it's because the dome is occluding or blocking the guide system. So can you hold down the fort while I do that? Both of you,
Sure.
I'm sure. All right.
Let's just hope it's not cloudy again.
Oh, no. Not tonight. I'll be back.
See, now this would have been a great time to plug the other show. now that Mark left.
Well, plug it again.
Oh, no. It's an interesting show.
It is.
I enjoy that show. It's a great addition to KGRA. They focus a lot on paranormal kind of shows. Carol Carl, who is in chat, she hosts Behind the Obsidian Curtain. That is Friday at 7 p.m. Eastern. I always have to add an hour back because I'm an hour ahead of Eastern. I'm in the Atlantic time zone, so check that out tomorrow night, actually. Less than 24 hours. Yay. 7 p.m. Eastern, Friday on KGRA.
Ta-da.
You can listen on TalkStream Live, on Spreaker. One day, I'll have some free time, and I will get with her to introduce her to StreamYard, and then you'll be able to see her here on YouTube and on Facebook. See the beautiful Carol. She's stood in here a lot of the times when I know when I've been MIA. I think she's joined Daryl a few times, but sometimes if he's not around either, she's done a wonderful job. Always great at posting links on whatever Mark's talking about and different sites to check out. So we really appreciate her, and I think KGRA family is a great sense of support, and all you guys that come to our community, to our SkyTour live streams, to Bill's live streams, Bill NY Skywatcher. By the way, this Sunday night into Monday morning, the Geminids meteor shower is going to be happening. I don't know if you guys touched on that or not, but I'll put his link in chat. He's in the Hudson Valley in New York, and hopefully we'll see lots of colorful shooters. So check that out. Sunday night into Monday morning.
Yeah.
What else?
Geminids are one of the best showers of the year. Some would say the best. Some would say the Perseids may rival them, but Geminids are a heck of a meteor shower. And Bill will be covering it with his new camera and new lens, no doubt. See lots of cool things.
Is that why it's considered the best? Because they're usually so colorful, or just more of them, or?
Yes, both maybe. Yeah.
I know Bill likes them specifically for the multitude of colors that sometimes the tails produce, but
yeah.
How do you know offhand how many we should see an hour?
Good year, 100 to 120 an hour is the usual estimate. That's what's called a zenithal hourly rate, though. That would be if conditions were perfect and the radiant was directly over your head at the zenith and you were looking in that direction. You might see 120 an hour.
So am I right to assume the comet will be going through Gemini?
The orbit of the comet does. It's a rock comet called Phaeton. It's not your typical comet. It may be an old asteroid that was the remains of a comet. But the comet's orbit, yes, from our point of view, it passes through Gemini. And every time the comet Phaeton comes through, it sort of reseeds the orbit with fresh debris, which is what creates the meteors that we see as Earth flies through the debris stream.
So is that where the radiant will be?
Yeah.
For? Okay.
Yep. The radiant will be right next to the star Castor in Pollux.
Nice. One of the twins, Castor and Pollux. Gemini representing the twins.
Yep. Castor is the one that is, when you see it rise in the east, it'll be the higher one. You might say it's farther west. As far as mythology goes, Castor was killed in a cattle raid of all things. And Pollux was a survivor, and Pollux was sad. And the gods commemorated them by putting them up in the sky.
Wasn't Pollux half god, though? And Castor was mortal?
I think you're right there. One of them was, and
Go ahead.
Oh, I should talk because I was a twin, but one of them, yes, was half god, I believe, and the other one was purely mortal.
Because I thought Pollux was so brokenhearted over Castor's death, he gave up his immortality to be reunited with him in the heavens as two twin stars.
Uh-huh.
And I thought that's why we see the two twin stars representing the zodiacal sign of Gemini, because he gave up his immortality.
Yep. If you see a good star chart, when you see Castor and Pollux, that's the heads of the two twins, and it's like they're standing side by side, shoulder to shoulder. Some even show them with their arms over each other's shoulders, and their feet are down toward Orion.
When Mark gets back, we'll try to get him to put that little picture thing up over top.
Sure. But anyway, the radiant.
I can't remember.
I'm sorry.
I was gonna ask something else about the shower, but I can't remember what it was. Anyway, if you do go out to look, make sure you give yourself about 20 minutes for your eyes to adjust to the dark. Try to get away from light pollution, obviously. What else? Well, any kind of pollution, obviously, like smoke pollution or whatever, air pollution. What else?
Oh, as you said, let your eyes dark adapt. Dress warmly.
It is December, yeah.
And don't focus too much in one area. Just try to kind of open yourself up to take in as much sky as you can. Relax and just wait for it, and you may be surprised how much you see.
I'm excited. Well, yeah, as Marsden's saying, if it's difficult to see in your surroundings, I dropped the link in there a little while ago. Danny Fan 1 just posted the link. Bill NY Skywatcher. Check that out on YouTube. I have no idea what time he's going to be starting. It would be after 10:30 p.m. Eastern, I would guess, unless he starts during SkyTour Radio. I assume there's a SkyTour Radio this Sunday. He'll want to get started as soon as possible, but it's going to be a long night, folks. So get your naps in early Sunday afternoon. Bring coffee if you drink it, and hopefully the weather conditions are good. No clouds or snow or rain, and it'll be raining here because it always does. Any kind of eclipse or conjunction or meteor shower or anything of interest in the sky, it is always raining here, or cloudy or snowy up in Nova Scotia, Canada.
We need to get you to Colorado sometime.
Have you ever climbed up one of the really high mountains to watch, like a specific like shower or conjunction or something? Yeah.
Oh yes.
Tell us.
The highest I ever set up a telescope was I was at about 11,200 some odd feet. I was on top of what's called Boreas Pass, which is southwest of the ski town of Breckenridge, Colorado. The road up there, it's an old railroad grade, and it makes like 26 or 27 complete circles. The number of turns, if you added them all together, to get from Breckenridge's elevation up to the top of the pass. And it was just beautifully clear, dark night. I was up there for the Perseids, if I remember right, which is the August meteor shower. That's the other big one of the year. And it was a beautiful, clear, dark night, and I hung around up there for a while. And even in the summertime that high up, it gets cold at night, and I wasn't dressed for it, so I wound up packing up and headed back down to lower elevations. But it was a beautiful night.
I don't know if the people know you used to take pictures of those kind of things.
I used to.
Okay.
That was back in the days of film, though, and I haven't kept up with digital cameras.
Yeah. Well, maybe one day.
Sorry that was so long.
We'll see.
No, everything good?
Yeah, I had to just confirm what was going on, and it looks like it worked because there is Alnitak right there, and
there's the Flame Nebula right next to it.
The Flame Nebula.
Yeah,
right
Tara was just asking if it was the Flame, and I was tending to agree. Or, oh my God, you just popped up on YouTube walking across the screen. That scared me to death.
Oh, really? Because you thought somebody was behind me?
No, never mind.
Okay.
It just...
No, it's okay.
I've been watching The Mole lately. I'm a little jumpy.
What have you been watching?
The Mole. Oh, old repeats of a show I used to obsess over. And apparently still do.
Apparently so.
I'm good.
Okay.
I'm good.
All right. Yeah, and, oddly enough, I looked out there and I noticed part of the problem I had was that there was a huge bank of clouds, but very, very thin and opaque, crossing over parts of Orion, and I think that's probably why I couldn't find what I was looking for. But when I went out there just now and I had it look for Alnitak directly, it found it just fine, because there it is. Well, there it was. Let me just show you where it is. It's actually right here. Okay, that's Alnitak. All right, and the Flame Nebula is right here. So, and we have another bank of clouds coming as well. So it's like, come on, give me a break with these clouds, huh? But, I don't know. Hey there, Martian, how are you? Okay, so I'm doing 30 seconds on the flame here. The flame should be right here. It's amazing. You can't see it, And Daryl, you asked me before, is it the Alnitak which is illuminating it?
Yes.
And I think we decided that it was, correct?
I think we did, yeah.
In the same regard, in the same way that when we look at the flame here, we know that the flame is a really interesting nebula. These dark areas These are dark dust lanes again. You can see they have a very interesting structure to them. This is a flare, a lens flare from Alnitak. Alnitak is a very, very bright, hot, young star. About 3 to 4 million years old, actually. It's really not that old compared to the sun's 5 billion years old already. But Alnitak is only just a few million years old. I've mentioned this before when early hominids, the hominids like Lucy, that you hear about, Australopithecus afarensis, was walking around, this star didn't exist. That was 4.2 million years ago, and this star wasn't there. So Orion's belt to Lucy would not have looked like a belt. It would look like two bright stars, maybe only one star, because it's possible that Alnilam wasn't there either. Maybe Mintaka was. And it's also possible that Betelgeuse wasn't red, as it is now. It's possible Betelgeuse was the hot, young O star, perhaps. And as it changed and evolved off of, after it ran out of hydrogen, it probably bloated to a red giant, and that's what we're seeing now. And Betelgeuse is moments from in stellar time, moments from a supernova, you know. And boy, and if you recall, it was dimming some months back, and Daryl and I were, and even Amanda, we were talking about it actually quite a bit here and there. And they're not sure still what the dimming was from, but they only have theories. Some postulated a dust cloud between us and Betelgeuse. Some postulated a sooty expulsion off of Betelgeuse, which actually blocked some of its starlight. That's actually the most likely scenario. And when we say sooty, well, in the same way, when we see this dark material here, right? This dark material is made of dark dust grains, and this dust is something that is all over the universe. It's everywhere in the universe, and it's made literally in red giant star atmospheres. And this stuff actually, as the star gets bloated and big, sometimes those outer layers kind of drift away from the outer star because it's so big that they're not gravitationally held, and the slightest stimulus from outgoing radiation from that star is enough to propel it outwards, and it keeps going. But as it goes outward, it cools. And so sometimes when it cools, it creates these molecules, and these molecules sometimes are carbon atoms that are diatomic carbon and so forth. And so two atoms of carbon locked together. And that's actually like soot. And so we get this soot in the universe as well. That's not why it's black here. We don't know exactly, why it's black here. It's dust. It's small particles that do not reflect light very well. We know that. And there could be a high level of carbon, but we also know that there's diatomic hydrogen gas out here as well, and that's just transparent. But the dust is a few microns in size, and it's that dust that forms planets eventually. Just lots and lots of it. And we know because we're here. And we know that what the Earth is made of is all these different elements that are in our periodic table. And every one of those elements that are in our periodic table that came from the universe was made in the heart of a star at one point. So it's hard to believe when you pinch your skin, you say, oh, look, I'm touching my hand. Everything you're made of was actually made in the heart of a star. Everything you're made of. And Amanda and Daryl have heard me say this a million times, and some of you have, it's like when we talk about what we're made of, my favorite astronomer, as I said, was Carl Sagan. And, he used to say, and this stuck with me forever, we are made of star stuff. And star stuff is that word that he coined, which I thought was pretty cool. And that's what he's right. Everything we're made of came from one of these nebulae at one point, and these nebulae at one point came from a star that blew up and scattered its remains to the universe. And these remains ended up becoming the material that we now look at and say, wow, that's pretty. But, as I said, the universe is changing all the time. That's all moving. You just can't tell. It's moving around. It's circling. It's probably orbiting other larger areas of star concentrations. All that is going on while we're just watching it. And to us, it looks static. It doesn't look like it moves, but it sure does. And the stars move as well, you know. And the motions that, like this star, you know. Let me just show you here. Okay, this is Alnitak. Okay, it has a little companion star next to it, and then there's this star. Well, these two are moving relative to each other. You just can't see it. Actually, you don't really even see it in a human lifetime unless you really know where to look. There are some stars, though, that really do move an awful lot. And we have seen that with Barnard's star, one of the closest stars to us. It's actually the next closest after the Alpha Centauri system. And it's about 6 light years away. And the star is amazing because it actually has what's called a high proper motion. That is, it moves against the background of the stars as it's moving through space at a very high rate relative to our view here on Earth. And over a period of about 10 months, you can actually see the difference in our telescope here even. So that's something that would be kind of fun to do, is like do an ongoing study of Barnard's star, you know, and watch it. So it's kind of cool. So the stars are always moving. The universe is always in motion. And I just absolutely, well, I adore it. You know I do. And I'm just so happy that all of you have, are here to see it as well. So I'll be quiet now and let someone else ask a question or talk if they want to. I'll try to move us to this location, the Casper the Friendly Ghost Nebula, if I can.
Speaking of questions, we do have one from Martian.
Okay.
They want to know, how massive is Betelgeuse?
Betelgeuse is about 20 times the mass of our sun, approximately. And if you put it where the sun is, you'd find that it actually would take up out beyond the orbit of Mars. Okay, it would actually fill all the space, Mercury, Venus, Earth, all the way out past Mars. That's how big Betelgeuse is. And hard to believe that Betelgeuse isn't even the biggest star. There are stars way bigger, you know, and that's something else. I'd actually like to show that to folks someday. I don't know if I can. Depends if we can see it. Can't see it tonight, I don't believe. But there's stars in Ursa Major that are actually really large too, from what we can tell. The New Horizons. Martian says, "Did you see the New Horizons?" What's that?
Yeah, you were just getting to it. I was just about to link it. You did skip a question. Maybe.
Okay, yeah, go ahead.
Daryl can handle that next. Go ahead.
Sure. Daryl, go ahead. Sorry.
New Horizons.
Oh, you want me to talk about New Horizons?
Yeah.
Okay, yeah. Martian says, "Did you see the New Horizons parallax experiment, where they took pictures from the Earth and New Horizons and compared it to?" Well, yeah, they actually gave us more data, and I think they were trying to. I forget what they were actually looking at when they did that. Daryl, do you remember that experiment? What they did with the parallax study with New Horizons?
I don't remember the particulars of it. They saw a noticeable shift in position of. If it was, oh golly, I don't remember the details.
I know, I'm right there. I had it in my head. I remembered, and I couldn't remember it. Yeah.
Hold on, I'm working on bringing up that link. Hold on.
Okay. Hey, Bob Harless. Bob joined us. And Michael's here. Hey, Michael. Matt Barron's here. Hey, Matt. Good to see you.
I'll try to answer Matt Barron's question in a moment.
Okay.
Okay, I don't know if this is what you're looking for or not. It's at April 22nd to 3rd. The spacecraft turned its long-range telescopic camera to a pair of the closest stars, Proxima Centauri and Wolf 359.
Yep.
So that was the parallax effect. Those were the two stars they were using, I guess.
Okay.
Is that right? Is that what you were looking for? I don't know.
I think it was. I think that's what they did. I'm trying to remember what the
The
results were.
combination yields a 3D view of the stars floating in front of their background star fields.
Yeah. Okay. You can't get that floating in front of the background star fields unless they actually get accurate parallax measurements. That is, the parallax angle, for those that don't remember exactly what it was, you can see what it is right here on Earth. All you have to do is hold your hand out, stick your finger up like this, and just close one eye and look at what the finger is against on the back wall. All right, and then you open and close the other eye, right? And then you just blink your eyes back and forth, and you'll see like it looks like your finger is jumping back and forth, but you see it against different things in the background. Now, if the distance between your eyes is the entire Earth's orbit, and this finger represents a nearby star, and the wall represents the much farther stars, now you see how parallax works. We use that to get distances to the nearby stars. I worked on a parallax program for years in a large observatory, and my shift was midnight to dawn. Astronomers, right? We're up all night, you think. And the midnight to dawn shift was interesting. Lots of things happened. Lots of, people would come by sometimes and try and play practical jokes on you, which is really kind of funny. Domes have a weird set of acoustics associated with them. So if you're inside the middle of a dome and somebody comes in and goes right to the very outside edge, and you may not even see them there, and says, "I'm here to get you," or something like that, it sounds like it's coming right in both ears because the way the sound travels. And all you have to do is whisper. It's an incredible thing to do, and I did that to a number of people myself, and it's scary because the sound comes in from all sides at once. It's really freaky. So that's what domes do, and I think that's probably what they're best at. Anyway, okay, so Amanda put the link in, and you were going to answer Matt's question, Daryl?
Yes, Matt. Yeah, we've talked about it a number of times.
What's his question?
It's all over the news now. The conjunction of Jupiter and Saturn, it's coming up on the 21st, which also happens to be the date of the winter solstice. Jupiter and Saturn will be just 1/10 of a degree apart in the sky, or about 1/5 moon diameter. I've seen different numbers. I've mostly been quoting the year 1623 since the last time this happened. I've seen other numbers that say it's the closest they've been since I saw today, like the year 1202 or something like that. But Jupiter and Saturn are only in conjunction once every 20 years. They term it a great conjunction, and it's going to do it again on the 21st of December. If you get a clear night and you go out and look now, it's worthwhile to look at it every clear night before then, because you'll see them drawing closer and closer together. They're presently, how much? Less than 2 degrees apart in the sky. I want to say closer than that. If you put your hand out at arm's length, you can easily cover both planets with the width of one finger. Yeah. And they're going to get even closer and closer than that. You can see them drawing closer night by night. You also need to look pretty early, though, even before it's totally dark. Like maybe go out about 5:15. I was out yesterday, and I can see both planets already. And they're setting by 7 o'clock here.
Yeah, same here. They're setting quickly.
Yeah, and by the 21st, you really need to be looking probably by 6 p.m. because they will set not too long after the sun, but they will be visible for a while after sunset. And it's, as I said, it's the sort of thing people used to measure their lives against. Nowadays, not so much. I mean, nowadays, a lot of people really don't care, which I find to be very sad.
Well, I think that the people that spend their time nowadays doing other than outdoor activities, the whole computer revolution has caused a lot of people to turn inward a little bit, whereas astronomers like me have turned around and used those computers as tools to look outward and find new fascinating things. This very stream is being brought to you by virtue of the fact that we have a tremendous amount of new technology that we can use and bring to bear to show you these amazing sights, you know. And I think it goes without saying that it's a double-edged sword, you know.
Yeah.
There's not a lot of people looking up, but there's also more people looking online. So we're taking advantage of that and saying, well, if you're not going to look up for real, we're going to help you look up virtually by going to your screens. I know a lot of people that actually take the SkyTour LiveStream and put it on their 80-inch televisions, for those that have them, and bigger televisions, smaller televisions. They put them on their... Oh, we've got a little dome interference here. They put them on their big screen TVs and watch. And it's almost like it's a TV show for them, you know, which I think is interesting. This is not a glitch, by the way, this object right here. This is, now we do have red because the dome, you know, a little bit of the dome is interfering here. If you notice that object right there, that's actually something called a nebula, right? It's a gas cloud in space. That dark part is actually a dark nebula, same as the Bay of Orion, that tongue of black that we saw, and it's going over the top of the brighter nebula. Same thing happening here, but on a much smaller scale. This is something called the 13th Pearl Nebula, or the Rubber Stamp Nebula. Is it Rubber Stamp or Rubber Stamp, right? Yes, Rubber Stamp Nebula, 13th Pearl. It's actually a very strange... In other words, it's a black eye nebula as well. It looks like it has a black eye for sure, you know. But hey, Genghis. And I tell you, when you look at this, you can actually see this really cool structure. Now, I gotta tell you something about this. We look at that guy, all right, and we see that this nebula, all right, has this beautiful black dust lane, okay, across the front of it, and that dust lane is similar to, and possibly similar to, the type of thing that causes Hubble's variable nebula to vary in brightness. But imagine that there's a dark dust lane in front of the star. Like, this is a much bigger version of that, okay? But if I have a star and I have a dust lane that's orbiting that star, like a big thick wad of dust and asteroids potentially, then every time it gets in front of the starlight to my nebula, the nebula is going to look dimmer, okay? Well, and as it goes around, the nebula gets brighter, and then it gets dimmer again when the thing comes around again. And when it gets dimmer again, that's when that orbiting dust cloud gets in the way of the star's light again. We think that's what's going on with Hubble's variable nebula. This is a little bit different in that it's a much larger object, a much larger artifact, but it's the same type of thing. This is a dark dust lane that's actually in front of a very intensely bright nebula. This isn't the star, this is the nebula. Okay, that's a star up there. That's a star right over there. Okay, that is a nebula. It has a star inside of it. You can't see that star. And then this is a dark, really, really dark, intensely thick, and therefore opaque dark nebula in the middle of that. And that's what that is, the beautiful dust cloud inside. And again, I got a little bit of the dome in the way here. Although I'm thinking that it might not be the dome, it might be a cloud. So in order to see that, I'm going to take another picture for 30 seconds and see if it changes, okay? And we'll come right back now to this.
Well, I'll hope it's the dome, because we can move the dome. We can't move clouds.
No, they move themselves.
Now, is Genghis right to assume that the dust must be pretty dense to dim that light?
Absolutely, Genghis, you're right. 100%. It's very, very dense dust. Although, you know what? What's dense? Well, we think that white puffy clouds in the sky are dense, okay? But when we get up there and we start going into them, we see that you can start to see through them, okay? And seeing through them a little bit, and then you go into them, you can see, well, when you get up close, they're not as dense looking. The density is an illusion from being far away, okay? And as you can see, we're getting a little bit more of this red, and that sort of implies that we might be looking at the dome. TD, haha. I keep a red light on in the dome so that we can see if there's problems with the dome intruding. We won't need that in Arizona because we have a flat roof on the observatory building out there, and it rolls off, and it makes you won't need the red light because everything in there will be clear. There will not be anything obstructing. All right. So that said, there's our rubber stamp nebula, and I want to come back now and just see now if that's a little bit of the dome, then it means that if I try to go to the Orion Nebula here, we're going to see more dome as well. But let's try that. And to do that, all we have to do is head up north a little bit. And let's go a little faster than that. Okay. I think I go more. Yep. And there's the Orion Nebula. And let me just show it to you in a way you can understand it a little better. That's a little better. Now, let's go see if that gives us a problem too with the dome. We won't do 30 seconds. Let's just do like 20. And now I wait 11 seconds after I move the telescope. Why is that? Because it takes 11 seconds for the auto-guiding system to lock on and latch onto a star so that it can guide for us. This gives us the ability to take long exposures if we want to. Alright, so now we can take our picture for 20 seconds. And we're doing it at 51,200 ISO, or sensitivity. That's pretty sensitive. And we're pioneering a new technique here. Daryl knows about it, where we take photos with very high ISO, because I have a system now. Yeah, see, we got some red in here. Starting to get the dome interference. Look at that, though, huh? It looks like a rocket. Like SpaceX. Incidentally, the SpaceX crash of SN8 was, Daryl mentioned this too, I think. It's due to a failure for one of the tanks to properly fill with the fuel when it was doing its belly flop run down to the earth. That's they can't come back down straight because it takes too much energy to slow that down. So let the body of the craft itself slow it down as it falls this way, horizontally, and then it stabilizes and goes upward. And because it couldn't get the fuel in there fully correctly, one of the engines failed to ignite, and it hit too hard, and that's when it blew up. But otherwise, it was totally flawless. Actually, SpaceX was very happy with that, how that went. Daryl, you were talking about it too, I think, yesterday.
Yeah. As far as SpaceX is concerned, it was a test flight, quote unquote test flight, and they considered it a success.
Mm-hmm.
I've seen some other people say that, oh my God, it was a horrible failure. But hey, SpaceX achieved 95% of what they set out to do, and they learned a ton from it, including the failure to land softly. Yeah. They called it a hard landing at the time. But as far as SpaceX is concerned, it was a smashing, call it a smashing success.
Smashing, yes, it did. Yeah, and I thought that was really interesting too. I watched the whole thing. In fact, I watched it from the time from the scrubbed launch earlier. What happened was, hey David Schmidt, welcome and good morning to you. They scrubbed it the day before, and then the next day, they actually had an aircraft flying, I think, Oakland to Barbados or something like that, wasn't it? It was flying from Oakland to like Barbados or something, and technically it was what's called a range violation, and the range violation caused the unfortunate condition where at the 2-minute and 6-second mark, the countdown ceased because it had violations, an aircraft within a certain radius of the launch. And kudos to them. They put it off for another hour and a half or whatever, and when they did, I watched it launch, and boy, did it it was really cool watching this thing go up there. I felt like I was watching Buck Rogers. It was like a big silver spacecraft, just like a 50s spaceship. And you know that somebody at SpaceX, probably Elon Musk, is saying, this reminds me of a 50s spaceship. I like it. You know, I think
I think
meant
he
that.
had that in mind the whole time.
Me
I
too.
remember first time I ever saw this, the Starship, they call it.
Mhm.
I thought, Jesus, that looks like something out of Buck Rogers.
Exactly, me too.
Or Chesley Bonestell or something.
Yeah, that's right. Yeah, okay, this is okay, this cluster we're looking at. Well, here, let me just show you. We'll just take a just to give you an idea what's going on here. We'll do 10 seconds at 20,000. Okay, just 10 seconds. Okay, we're probably all locked on, and this will tell me whether we have dome in the way or not. I've just gone west of the Orion Nebula. I'm sorry, east of the Orion Nebula, heading toward the east. And so technically, we don't have a problem right here. That's good. That's a beautiful cluster that we're looking at right there. And when you look at this cluster, it doesn't really jump out at you as being remarkable in any way, other than it's just a pretty cluster of stars. But let me show you now what happens when you take a slightly longer exposure. Okay, now we're going to go up to 30 seconds, and we'll go up to 40,000 ISO. Okay, and we'll take a 30-second picture here. So we'll be looking. We were looking at this. Okay, nice, beautiful little stars in the cluster. And what you miss is something else that's going on in here. Now it'll be visible. A little bit of it will be visible over here to the right. In this exposure, and maybe a little more will be visible. And we're using what are called the narrowband filters for all this. Anahata 77. Hey, I forgot to say hi to you before when you were here. I am sorry. Hi, Bonnie. Oh, yes. Now, and Ronald is here. Hey, Ronald. Now look at this. Now we have this cluster in the middle. But look around the outside now. It looks like it's surrounded by a ring of nebulous detail. And that's because it is. It almost looks like a rose, right? And that gives rise to its name, the Rosette. This is the Rosette Nebula, east of Orion, in the constellation of the Unicorn, Monoceros. And it's got some beautiful detail in there, Daryl. Look at that. And this is just a 30-second shot, yeah?
Yep. Monoceros literally meaning one horn, of course.
Yeah.
Hence
Exactly.
the unicorn.
Yeah. Let's risk going a minute on this.
The Rosette's another one. I think I told you yesterday about the guy from the Astronomy Club with the 13-inch knob he built. He showed me the Rosette one night through that same 13-inch telescope. He was partial to a hydrogen beta filter.
Mm-hmm.
And it just jumped out at you. I mean, it looked like the photograph, except it wasn't pink or red. It was gray.
Wow.
But you could see so much nebulosity. It was amazing.
Now you heard Daryl say he saw it through a 13-inch Dob.
Yes.
That's short for Dobsonian. That's a style of telescope. Whereas the one I have here, this one is called a Schmidt-Cassegrain telescope. Folded optical path. So a lot of power put in a very small package. Dobsonians tend to be big, long light buckets. They look like cannons. The light goes down, hits a big mirror, comes up, and goes out through the side. It's just an immense, light bucket, I guess is the best term for it,
Yeah. Well, it's a Newtonian telescope.
Yeah.
It's like the one Isaac Newton invented.
Yeah.
Just a mirror in the bottom and a little diagonal mirror at the front to
Yeah.
shoot the light out the side of the tube.
Yep.
This telescope, it was the junkiest looking thing. It had started life as a so-called Coulter telescope, which was a brand back in the early days of
I remember
Dobsonian telescopes.
I remember Coulter.
It was just a big old ugly cardboard tube on a mount, big old bulky thing, and he took the mirror out and built another mount for it, a mirror box and with trusses, so it was an open design.
Wow.
And it, like I told you, it looked like something from Sanford and Son. It was really junky looking telescope. The guy really nailed the construction because it had excellent resolution.
That's great. I'm going to make a few adjustments here. Well, I think that's, a beautiful telescope. It doesn't matter what it looks like. What matters is how does it perform.
Sure.
And that's what you're trying to suggest here, is that it performs tremendously.
Oh, yeah.
Okay, I'm going to just add a little bit more here because I want to be able to show everything, because we can't see everything right now. Okay, so let's go up there, and then we're going to take this down here a little bit. Okay, is that about as far as I want to go? And then, all right. So there we go.
This is one that wide field telescope will come in handy for once you get to Arizona.
Yeah, the wide field shows this beautifully, actually, even from here. So this is the narrow band. Now what I'm going to do is come back to this, and this is, again, oops, sorry, let me just forget to sometimes bring us into that screen. All right, and what I'm going to do is go up to here. And if you look right up here, you see that it says disconnect wheel, and then right underneath that there's some arrows. Okay, and what we're going to do is we're going to go up to narrowband 1 by hitting this left arrow here. And now you'll notice there's a blink on the screen. Only the brightest of the stars will show here. Okay, and we're now going to go up to 51,200 ISO for 1 minute and take a picture of the Rosette. And I'll show you the difference between what that wider narrowband filter sees and what the narrowband filter sees. The narrowband, what I call narrowband 1, shows us some incredible detail, but the detail that it shows is only the detail of the nebula. It doesn't show any of the light pollution or any of the other stuff around. We get some really good shots here because of these filters. Without the filters, SkyTour LiveStream could not exist. We would just see stars and probably do clusters, and that's it. But look at that. There's that cluster. Again, these stars were born here, and they've cleared this whole inner area with their stellar winds. And then out here, they have ionized the hydrogen gas way out here and caused this entire nebula to just glow from that process. But now, look at this. Now you can see just how much more detail shows up. And let's just do some instant processing here right there just to get rid of some of the noise. If you notice, there's these dark lanes here that are very, very obvious. Okay, and there's some intricate details in this nebula right here. And if we were to go a little longer, we might see an even more detailed view. And I think I may dare to do that because I'm crazy. I'm just crazy. It gets just crazy. Right now we're doing 1 minute and 0 seconds. I'm going to do 1 minute 30 seconds. Let's just try that. No, 1 minute 45. Why not live a little? Okay. All right. This will be a minute and 45 second long exposure. So this is with the narrowband number 1 filter. Okay, very, very narrow view. This is the view with the filter which views slightly wider swaths through those little narrowband windows. Okay. Yep. So now, yeah, they look like Tara. Thank you. It looked like a blue rose. That's true. That's because we are not taking quite a long enough exposure. That's why I'm doing 1 minute and 45. So if we go a little longer, this will start to look reddish. But notice this area right here. This is really cool. When we look at this area now, the stars have a little bit of a streak to them. We might get a little bit more because we're fighting some of the telescope's instability issues. But look at this area right here. Look at how convoluted and complex that is. Okay, you can see some of the noise. You can clearly see noise in here. But we figured out a way to get rid of the noise. And as Daryl has seen, some of the images we've come up with are just like night and day to what we used to do, you know? So I think that's pretty cool. So let's see what 1:45 does. Hopefully it comes out reasonably well. It's 45 more seconds, almost another minute. So that doesn't necessarily equate to twice as bright, but look at that.
That's looks like what I saw on that 13-inch telescope with the H beta filter.
Okay.
You couldn't see the color, but you could see all the convolution in the nebula.
Yep. So this is an example. So here is what happens when you don't quite have a long enough exposure, but you add one now that's a little longer, and look what you get. Okay, now you get a little more detail, and you can start to see all these complexities here. Over here, there's a lot of complexity in the Rosette Nebula. So this is the Rosette. Look at now how bright these are that stand out so brightly. Now you might say, well, is that the real color? Is it really like a purpley magenta? And the answer is no. It's actually red. Now, we could probably monkey with this to try and get just a little bit more of a proper hue here. And so if I add some type of a color correction to it, then maybe what we could do is get this to look more like it's supposed to. So let me try that. Okay, so that might be more. See, we can go to all ends of the spectrum, go like a Hubble palette even. Okay, so we can do a number of different methodologies here, and you basically show it in the colors where it shows the best. And that's what the Hubble palette is, by the way. When the Hubble telescope images show you things, those aren't the natural colors. Those are the colors that show the phenomena the best. Okay, so that's pretty cool. And what Daryl was saying before is interesting because if we look at, let me just set my defaults here again. If we look at what he saw, what he was saying was it probably looked like this in that 13-inch telescope. Is that more like it, Daryl?
Yes.
Yeah. So this is where you take the color out. Now we can add saturation, add colors, but it's a fine line. You don't want to go too much because we could easily add way more than is actually there. And it could add some real bad characteristics if you're not careful. But there is the Rosette, and it's just a beautiful nebula location, and that's with the tightest narrowband filter. Isn't that pretty? Gosh, that's gorgeous. Wouldn't want to live there, though.
Excuse me a moment, please.
Sure. Okay, so let's now, number one, let's go over and go back to narrowband 2. So we're going to go back to our other narrowband filter there, which is going to give us that view. We can see more stars now. And let's now go look at something else, if we can get to it. We talked about it just a moment ago. It's Hubble's Variable Nebula. Okay. And Hubble's Variable Nebula is that nebula that I was referring to when I talked about the rubber stamp nebula, right? And how its brightness varies, how its brightness can vary. The rubber stamp is not a variable nebula, but this one that we're going to see is a variable nebula. And so I will show you that momentarily as soon as the telescope decides to find it for you. generally, when it tries to find this, it puts it near the center. But I can see with our view here where it is located. Here it is. It's right there. And every time we've looked at it in the past, Daryl and I and Amanda, we've noticed that it has looked different because it's variable. Do you remember that, Amanda?
I do remember that.
Yeah, sorry. Hope you weren't sleeping back there. I know that I'm just going on and on here.
No, I'm here.
Okay. It's good to have you, by the way. Thank you so much for coming.
Thank you.
I'm so happy.
Sorry I was a little late, but
I thought you weren't even going to be able to make it with iDetective.
Yeah. No, it's all good. I'm here.
Tara, don't give me jelly legs here. You know, when Tara created our door, which for those who haven't seen it is this right here. This is the door of the observatory right there that you're seeing on the right side. And it's made of bottle caps that she artistically placed in there to look like an Orion Nebula and then our logo. And she did a really, really nice job. And I can't say enough. The woman is just so talented. And so that said, we can't wait to see it in the building. But there's a door handle too to get in. And because they're bottle caps, what do you think the door handle is? Amanda, do you have any idea?
The red swirl on the left?
No, it's actually not on the door there.
Oh.
It's actually not on the door as you see it there. It's something, it's going to be added to the door as the handle. You know what it is? I'll tell you.
What? Tell me.
A bottle opener. You know, like the one
very cool.
The one that's on the Coke machines, right? You stick the bottle in and pull up.
Okay, I got it. Yeah.
Yeah, isn't that cool?
Very cool. It is very cool. Did you? I guess you told them about the game, about the competition, or is that over?
No, it's not over because nobody's guessed.
Tell them.
Yeah. Okay. I basically, in this image, it's on my my Facebook page too, so you can see it in full size and actually get up close and personal and see it. I said if you guys can figure out how many bottle caps are on the door, that I was gonna send you a free 3D lunar printed. I'm sorry, 3D print of the moon. It's a sphere, and I have it actually behind me, and I'll show you. Winner, chicken dinner. Yeah, I don't know. So, yeah, let me just bring this up here too, because this is cool. Okay, we're gonna take another picture because it's trailing a little bit. Yeah, so if you can guess how many bottle caps are on the door, then you can actually you'll get a 3D printed spherical moon, and we actually did it with our SLA printer, so you can see every crater right down to the most tiny thing almost. You know, they're not every crater, but you know, it's a 2¼ inch diameter moon, and it comes in a little stand like a cradle. And you can actually take that and examine it and enjoy it, turn it any which way you want, and set it on the cradle any way you want. So you can look at the dark side, I'd say far side of the moon, not the dark side. You can look at the near side, you can look at the lunar poles and everything. And it's really accurate. And it's data from curated NASA data, so it's really, really beautiful.
And how do they tell you they're about?
Okay, if you have when you go to Facebook and you look at that Facebook message I put up there, the post, you can message me a private message, and in that private message you have your guess. If you're and I'm gonna make it this way, you don't have to be exact. You have to be within a certain number. That certain number, I don't know yet what I want to use for a certain number. It might be 10 caps. It might be 20. Okay, but if you make a concerted effort to count, you should be within 10 or 20. Keeping in mind that some are overlapping, okay? And you will be counting for a while, no doubt. Have you seen Tara's work? You know?
So can I put your Facebook link in the chat?
Oh, please do. Sure, thank you.
Really?
Yeah, that's okay. See, these are.
Hey, you guys heard it. You heard him give me permission.
Of course, you can go right ahead. I mean, all they have to do is go into Facebook and search for Mark D'Antonio. What do you think they're going to find? They're going to find my Facebook page. You know, it's okay. Yes, there's a hint there from Tara herself, the artist. Less than 1 million. She's funny. Yeah. And while you're thinking about that, this again, as I said, is Hubble's Variable Nebula. Now, you might think that this star right there is the one responsible for lighting up the nebula, but that's actually not the right star. That star is not the one lighting this nebula. Okay, the star lighting it is inside the dark nebula over here somewhere. Yes, this is more dark nebula up here, which comes down around here and goes all throughout here. And this is just a little edge that's sticking out enough to be illuminated by the star from inside. Now, the lighting that's being done on this is actually lighting that's done through what's called a reflection nebula only. This is dust in here. It's not gas being excited and caused to glow. It's actually dust. And the dust is reflecting the starlight from inside this dark cloud of dust, right? So it's more dust. This just happens to be at the edge. It's a really clever location. It's really cool. And so that's what we see here. And I think that the Hubble's Variable Nebula, you know, and Daryl, I think you're back now, right?
Yes.
So remember we looked at Hubble's Variable Nebula in the past, and we've seen it was different almost every time we looked at it.
Oh, yeah.
And now it looks different still. It depends how you catch it, you know? Depends how we catch it.
Yeah, if I remember correctly, I think I proposed last winter that if we imaged it on some kind of a regular basis and maybe march through the images, you could see the changes over time.
Yeah, I'd actually like to put together a little video of that. You know, that'd be kind of cool.
Mm-hmm.
I don't know the periodicity. I don't know how long it takes to go up and down. I think it's like, was this like 240 days or something crazy like that?
I don't know offhand.
Yeah, I'd have to see.
I've heard, though, that it changes on very short time scales.
Oh, okay. Well, that's something. Yeah, and see, you know, that's the other thing, too. And Daryl reminds me that, which is a really good thing here. When we look at these things in the universe, I've told you before, the universe is always changing around us. And if you're not, you know, if you're not conscious of that, then you can miss something crazy. You know, we actually imaged the comet Neowise some months back, and Daryl, you were with us, I believe, and we imaged it for about 45 minutes. We kept taking pictures of it every 45 minutes, or every few minutes. The reason I did that was not to bore anybody, but to then show you by the end of the night how it actually moved against the stars. You can actually see that it moved against the stars by quite a bit in just 45 minutes. You know?
Yes.
So that's pretty cool. And we did that with Comet Holmes. We did that with another comet, and we did that with an asteroid, which is really, you know, crazy. You know, but it worked. You know.
Yeah. There was oh golly, which comet was it? Hyakutake or Hale-Bopp,
Oh, yeah,
or maybe
okay.
both. I forget. It was not conducive to catching in imaging at the time. Of course, I was using film back then, but
Okay.
just look at it by the eye. I mean, you can see it change moment to moment, and you can see the comet actually, the nucleus of the comet spinning.
Really?
The coma of the comet, you can see jets coming out of it, and see the
Wow.
thing slowly spinning because of that, the jets, and you can see it, you know, like you can see it change minute to minute.
Wow. I remember Comet Kohoutek, and I remember Comet Hyakutake. I remember Hale-Bopp. I saw Hale-Bopp looking right up over my head here in this very town. It was right up overhead, and it was really stunning, you know, to see it right overhead. I was like, wow, that's crazy.
Oh,
You
yeah.
know? That was, of course, many years ago.
Well, don't make me feel old. It wasn't that long ago.
No.
Hyakutake was 1996, and Hale-Bopp was 1997.
Yep.
23, 24 years ago.
Yep. remember exactly what I was doing. I was actually out in my front yard, exactly 1 mile from here, because that's where I lived at the time. And it is really 1 mile from here, 5,280 feet exactly. Don't ask me why I measured, but I did. I had a feeling, and it's exactly 1 mile from the end of my driveway where I used to live to the end of my driveway where I live now. It's almost kind of creepy, but it's not 6 inches off. It's pretty darn close. So anyway, this object here we're looking at, this is, well, I'll just show you. I'm going to go up to 51,000 again. Looks like an ordinary, actually I'll go 32,000. And we'll do for 30 seconds. See what we get, see if it shows us. See if it gives itself away. You know, it's a location just east of Hubble's Variable Nebula, and that means to the left. Okay, and it's a location where we have something called the Christmas tree cluster and a nebula called the Cone. I've been waiting all year for the Cone Nebula again. It's just beautiful, because I want to get a beautiful stacked set of images of the Cone that you guys will be proud of. Oh, and you can see the Cone. Look at that. See that, Daryl? Here's the Cone right here. And these two stars are right at the top of the Cone. It's right there. Let me see if we back out. It might show better. See? See that? There it is. That's only 30 seconds. And we got an interloper. You'll notice in many of our images, you're going to see little streaks. We have satellites that will travel through, and depending on where we look, if you look around the celestial equator, which is kind of sort of where this is, you're going to end up seeing satellites going through your view. There's actually two here. There's another one underneath this. It's very, very, very faint. Very hard to see it. In fact, now I'm doubting whether I'm even seeing it at all. However, and we're going to try this again with the Cone. And we're going to go to a full minute. And we'll go to 40 and then 51,200. So we're going up several stops in photographic parlance here. Okay, and then back to our view here. How pretty. And just above this is the Christmas tree cluster, which we're going to look at as well. Yes, Tara was collecting bottle caps for many years, knowing that she was going to do something with them eventually. And being the door has kicked her of the hoarding habit. She is no longer hoarding bottle caps. In fact, I don't think she wants to see another bottle cap for quite a while. Is that correct, Tara? Yeah.
My sister inspired me with bottle caps a very long time ago. When she was always something of a groundbreaker. When she was in high school, she took shop classes, which was almost unheard of at the time. This is back around 1970, I think. Wow. And she took a welding class, and she made some flowers by brazing skinny brazing rod onto the bottoms of bottle caps.
Wow.
The old-fashioned bottle caps, you know, the ones you actually had to pop off. And she did a little artful torch work on the bottle caps themselves to make them look like petals, and she built this sculpture out of it, and I was just amazed.
Wow.
And that inspired me ultimately to take welding classes much later in life, and some of the first things I made were flowers.
Really?
Oh yeah.
Wow.
She was
flowers, too.
also.
I've seen pictures.
Oh yeah. Okay.
Yeah, they're gorgeous.
Um,
Very delicate work.
There's the Christmas tree cluster up there, and here is the cone. We're white here. We got a little white in here. I'm thinking that there's a cloud in our way here, but we can test that theory. I'm just gonna go back. So Daryl, where are these flowers? I mean, where are these bottle cap flowers?
I gave them all away.
Oh, you did?
I've never sold anything I've ever made. The one Amanda said she saw a picture of, my older sister has that. It's over in Hawaii now.
Wow.
All the other ones are scattered to the four winds. I don't have a single one. Some of the neatest ones I made, I wound up making out of copper. Most of them I made out of stainless steel, but some I made out of copper, and I found that if I heated the copper and quenched it several times, it turned a beautiful kind of rose red color. So I made roses, and I gave those to a lady I knew many years ago.
Wow. That's pretty cool.
The sister
Yeah,
I mentioned, I'm sorry, say again?
Go ahead.
Oh, the sister I mentioned who made the original flowers that were served as my inspiration, she, what was it? She was musically inclined, and she wound up playing the bassoon again back in the day, you know, the great biggest of the woodwind instruments.
Yeah.
And she was invited to play on the city orchestra in our hometown.
Wow.
And she was the first female federal judge in her federal district court.
Wow.
She's retired now.
That's pretty cool. Let's see.
Yeah, and her having inspired you for flowers, you might have inspired Tara. She has some leftover bottle caps and might be making some flowers out of them.
Ooh.
Oh, cool.
Oh,
Yeah.
the inspiration flows.
And Genghis, you may not, maybe others don't know this, but when you say bottle cap flowers for Algernon, I know the book Flowers for Algernon, as a matter of fact, because a friend of mine had to do a book report on it, and he picked the book to read and didn't realize, you know, anything about it and thought it was a silly name, but he ended up liking the books, which I thought was pretty cool. I never read it.
Harlan Ellison? I forget who wrote that.
Okay, maybe it was. I don't know.
I forget.
Okay, that one. Okay, what I'm going to do now is we're going back here. And I'm going to move up now a little bit because we're just picking up the cluster. Let me just bring us down to a little bit of a slower gait with our telescope. All right, and so now, within the same field of view, we're going to have the Christmas tree cluster. Right, let me get this back to where we can see a little better. Christmas tree cluster here, and the cone down here. It's really kind of cool.
No, it was a guy named Daniel Keyes wrote Flowers for Algernon.
Okay. Okay, so now we have our guide star, and I can take the picture. Ah, yes. Hey, folks, I want to thank you guys for coming out tonight. We're having a ball so far. I'm having a great time with you. And Daryl and Amanda, thank you guys for coming out. I mean, I'm glad you took time out from your busy, busy days to come hang with us. Or hang with me here and make this all work.
I can't speak for Amanda, but for me, that's funny right there.
What's funny?
Busy day.
Yeah, I was on mute, but I did laugh at that. I didn't realize I was on mute, but yeah, I don't know if that was directed more at me. I know I've been swamped lately, and I feel bad for the ones I've been missing, but I'm glad that you still had me, even though I was late. You still allowed me to join. I appreciate that, and
I would never
I
disallow
love being
you.
in this community, obviously.
I would never disallow you. You belong here.
I know. Thank you.
Yeah. You know, like I said, this observatory is more than just me. Obviously, everybody who's coming out to see it. I mean, after all, what is it without people saying, wow, look at that, that's beautiful? I mean, that's what this is all about. I mean, where can you get a cluster like this? Okay, where you have this beautiful blue reflection nebula up there, and then down here you have this beautiful, you have this beautiful nebula down here, this beautiful red nebula, okay? And this location right here, this is the cone right here. This is a beautiful location. This is all so beautiful. And we're actually, even though I think there's light clouds out there right now, I do have to go look. I should go look. Because I'm not getting the performance from the filter that I expect. So I think it's because there's a very, very light cloud cover out there right now. Normally I have my all sky camera, which you guys have seen before, where I cut to that and you actually see the entire sky. But that's packed up behind me because that's ready to go to Arizona. It's one of the first things that's getting installed with the computer is the all sky camera. And then while that new telescope is working out there for us, I'm going to be back here working on the new mount for the 5-inch refractor that we're going to put out there eventually. And the 5-inch refractor is going to have its own computer controlled mount, and we're going to be putting that through the paces out here as well and making sure that that all works right. And then once that's all working right, we do it out here and then we put it out there. And then in this observatory we reinstall the old telescope that we have after we get rid of the dome. We're going to be selling the dome to this observatory. So if anybody wants an observatory dome, we'll be selling it. It's from Next Dome, which comes from Canada. Ta-da, Amanda.
Yeah, Canada.
Yep.
Sorry, I can't get off mute fast enough tonight.
That's okay. And the guy that sold it to us has been very, very helpful. It's a great product. It's meant for a telescope that you're going to be running yourself with you in the dome. That's what it's meant for. It's not meant for remote operation. I mean, they're trying to make it that way, but there's too many variables with this. It's made of polystyrene plastic, so there's flex and motion, and that's not good. And the other thing is that it also has the inability to withstand very strong winds. We've had the shutters, the things that open and close in the front to let the telescope look out. Those have been ripped off 3 full times now and have been replaced 3 full times for free by them. They're very good about that. That's one thing they're really good at, is customer service and so forth. And but they installed, I actually got from them and installed a shutter system that holds the shutters on. And we had 75-mile-an-hour winds during a hurricane remnant that came through here, and they didn't budge. They were perfectly fine. So they rated only for 50-mile-an-hour winds, and they withstood 75 in an ongoing manner. So this system to hold them on is really quite nice now. And then we're going to turn what's out there now into a roll-off roof observatory like Arizona. And Arizona's roll-off roof can be controlled from here, 2,400 and some odd miles away. We can actually control it and run the telescope the same way that we're doing this one. This is a remote telescope as well. So I think that's a really, really good thing. You know, the roll-off roof is nice and flat. The wind can't catch it. It rolls off. All right, then it rolls back on, covers the telescope. You know, when it rolls off, the telescope only then can it be powered up and look around and start doing its thing. And then only when it is powered off and parked can you put the dome back on, or the roof back on. And that software that allows for those, that the order of things, and that allows all those things to happen and does all those things, is software that I wrote here, and I'm using in the dome. And that's the kind of thing that I used to do a lot of anyway. So here's the Christmas tree cluster again, with a Narrowband 2 filter, slightly wider, and you can see all the convolutions in there. It's really pretty. And then down here is the cone. You can see that dark nebula right there.
Okay, Yeah, I see the cone now.
Yeah.
And did you mention that the Christmas tree is upside down?
I did not, but I can show people that right now. If we come back over here, we can just say it's upside down, and we can just do this. See, now it's right side up.
Yeah, bright star is the base of the tree.
Yeah, right down here. And here's the sides of the tree, and they go up like that. And actually, the cone is just to the right of where the tree topper would be, right?
Mm-hmm.
So, but now you can actually see the cone a little better, because when you reverse things or spin them around, sometimes you can actually see things better. Yeah, and so let's turn it to the right. And there. Now when we look at our imagery, the bottom here has this red glow you always see. This red glow is actually due to the sensor of the camera and the amplifier. It's such a sensitive sensor that the slightest electrical current nearby can cause it to get false color loading on it, and that's what we're seeing here. So this bottom little reddish thing looks sort of like sunsets, right? Is not that. It's actually noise from the camera, which we can remove and do remove in our final shots. But this is pretty. This is looking really pretty. I just want to move us up a little bit more and try a couple more shots of the cone itself. Okay, so the Christmas tree cluster is going to be out of the shot. And then this is what I want. The cone right there. You can't see the nebula. It's actually quite faint. But the cone is right under here. And that's kind of a cool location. We can sort of maybe show it a little here. Well, we'll see. The telescope is lined up, and the guide star has been captured. So let's take it and do a minute at 51,200 ISO, and we shall see our cone. Amanda, did anybody ask any questions that I might have missed?
I don't see any as of yet.
Okay.
Did I miss any? Hold on. A million things open here. None that I missed. You guys are doing fine.
Good.
If you do have questions, though, I am keeping my eye on chat, so let us have it. Try to stump the hosts.
Let us have it. What does that mean?
I don't know.
Come on,
Trying to get the chat room riled up a little.
kick their butts. That's okay. I never have any, I don't ever, whenever I do anything like that, I don't ever ask for questions ahead of time. I'd say, like, just, ask me anything you want. I don't have a problem with that. Oh, look at that, Daryl. That's really nice.
Sorry, muted.
That's okay.
Yeah, that's a little more obvious now.
Yeah, that's really pretty. I'll take a couple of those. And so, in order to take a couple of these, what I need to do is...
Still in Monoceros, isn't it?
Yes. I move over a little bit. And you say, well, why are you moving the camera a little? Why are you moving the camera? Why are you moving the telescope, in between shots? That process is a process called dithering, and I do it manually. Other people do it with automatic programming, but I do it manually because I feel I can control the noise better. What happens is, when you look at the sensor, and once I start this picture, which I'll do right now, we have our 11-second guide star lock time down behind us. Right? When you look here at this shot, if we zoom in, okay, you see this noise, this nasty looking mottled noise. Well, left to its own, okay, the telescope may drift a little bit as it's taking pictures. As it does that, then this noise will kind of be in the same place. Like, okay, this black splotch right here will then be here, and then be here, and then be here, and then be here. And when it does that, it's going to make kind of like a line, and it's going to look like it's raining in your shot. Okay? Raining weird things that really aren't there. And those are artifacts of the noise in the sensor. So what you do is you move over and up, and then you move down and left, then you move up and to the left. I mean, any direction, just randomized. And that eliminates the ability for the noise to become a regular pattern. And then what we do is we subtract a noise pattern that we have previously done. All right. And that noise pattern becomes this master noise file that we can subtract the noise out with and in part. Okay. So that's pretty cool. So I'm going to now come back over here, and I'm going to move a little bit more. So as you can tell, we're doing a sequence now, a series of pictures. Okay, over and maybe this way. Okay. And now we wait our obligatory 11 seconds.
Be right back again in just a moment.
Okay. Now take a picture.
We do have a question coming in now that
Okay.
now that we're kind of looking for some.
Okay.
Ronald wants to know what the center would be on an open cluster.
What the what would be?
With the center, like, you know how like a closed cluster, there's like a star in the middle.
Well, open clusters are clusters that just have a bunch of stars in them. There's no border per se. All right. And there is no closed cluster. So I'm not sure what he's asking. Is there?
Well, as opposed to like maybe a planetary nebula or something like that.
Okay.
Like, is it an exploding star that's causing the openness? Like, it's causing it all to spread out?
No, actually, in an open cluster, what happens is the stars are born in this hydrogen gas, right? And maybe early on, they cause that hydrogen gas to glow. Maybe. Okay? However, that glow is soon dissipated as the star's stellar winds, like our sun has stellar winds that push out. That gas gets moved further away from the stars because it's so small. It's hydrogen atoms, right? And it gets moved out away from the star. And as it moves away from the star, it'll get to a certain point where it no longer can be ionized gas or caused to glow by the star. And that's something that which is really dictated by how powerful the star is. All right. So if the star is not very bright, not very hot, then it can't do that ionization. But if there's dust there, maybe you can do a reflection nebula. And so open clusters are just clusters that have already pushed away with their stellar winds all that gas that may have been glowing at one point when those stars were younger. Hopefully that's helpful, Ronald.
I asked him to add clarification. He said it was a good add on my part. I'm not sure exactly what he meant, but the church story. Hold on. Oh, okay. Never mind. Sorry. Never mind. That was to another question in chat. Had nothing to do with on our conversation. Never mind. I'm okay.
No worries.
Yeah, well, that's what I assume, because like sometimes like you point out like a star in the middle of a cluster or something, or a nebula. Maybe he's confusing it with the nebula. Star being in the middle of a nebula or something. I'm not sure.
Okay, maybe.
Anyway, tell us more.
Oh,
Everything all right?
Yeah, everything's fine. Yeah. There we go. There's the cone again, and if you notice, we have a satellite coming through this particular shot. See that? Look, Daryl, we got a satellite.
Yeah, I see that. Isn't it rather late at night for satellites this time of year?
No, it's 11. Usually we get satellites that you can see satellites all night long as you look at higher altitudes. If they're in higher altitude orbit, then the sun can still get to them, and they don't necessarily get blocked by the Earth. And so this is an example of one of those. And this was a 1 minute exposure, so it took 1 minute to go from here to here. You know, and it did go from right to left, by the way. How do I know? I'll prove it. I'll take another shot right away, and it'll be a little further over, I would think. Most satellites go from west to the east.
Yes.
So when we look at them in the sky and see the traces, we tend to think that there might be more eastward. If we have a streak over here, right, and east is that way, then we're going to guess that the rest of the next track is going to be over there as well.
Roger that.
Roger Dodger. Remember in Star Wars, the little battle droids? Roger, Roger. Roger, Roger. You don't remember that?
I think we've touched on this question before. Sorry, Daryl, go ahead.
No, go ahead.
Oh, just if all the stars in a cluster, in one particular cluster, are all the same age. I feel like we've discussed this before, but
we have indeed.
For those that might have missed it.
We have indeed. I know the answer. Daryl, would you like to take this one? But
I would say they're roughly the same age.
And he's correct there, Ronald. So there is the satellite, by the way. I told you it was going to appear a little to the left, and sure enough, it has after another minute exposure. So it went from here to here. See that? So that's actually pretty cool. And I just took a couple exposures to show you that. And now I'm going to just drop it down and head east a little bit. There we go. Alright. Doing the dithering again. When a cluster is born, Ronald, all the stars are forming roughly at the same time, as Daryl just said. And so you would find that they're roughly the same age. Which is why when we find clusters that have something odd going on in them, it catches our attention. For instance, there's one cluster that has a planetary nebula in it. And Daryl, I'm sure you remember the cluster's name. We can probably see it sometime soon tonight.
M blah blah. It's in Puppis, M46,
That's
M47.
Right. M46, I think it is, yeah. And it has a bunch of young stars, and then right in the middle is a planetary nebula of a star that has already started to die. And you're like, wait a minute, what? That can't be. This is a young cluster.
That one's a foreground object.
Well, that's where I'm going with this, to see, that's what we see. And so it was perplexing until we could get the distances to all the stars. And we found that the distance to the cluster was just about 4,000 plus light years away. But the distance to the planetary nebula was just like 2,300 light years away. It's literally half the distance away. So you'd encounter that star long before you encountered the cluster further away. And that's why it's a line of sight illusion. That's all it is a line of sight illusion.
I have heard of one or two instances where there really are planetaries inside globular clusters, I think.
Well, globular clusters, yes. That's right. Not inside open clusters, though.
Yeah.
Yeah. Yeah. And now our satellite is gone. Okay? Because it's already moved out and passed. Kind of interesting, huh? How we just sort of catch something briefly in the sky and then it's gone one moment to the next. It's kind of cool. I like that. Okay. And again, I'm just dithering away here to get the... I just moved this over a little bit and up to get this set up again. And after 11 seconds, we should now have our guide star locked and I can take another picture. Now you might say, why am I doing all this? Well, because what I'm going to do is I'm going to create for you guys, I'm going to create a image of the Cone Nebula. And we're using a new technique. You take them at a very high sensitivity on the chip. Now you might say, well, why do that when you get all this noise? Because I can get rid of all the noise. And I have a technique for doing that. I use product from Topaz Labs, and it actually is an artificially intelligent denoising system for astronomical photos. And depending on how well it does, we might end up with a very spectacular shot of the Cone Nebula. And I'll tell you, many of the shots I get that are spectacular, they have less apparent detail in them in these raw shots, okay, than this shows. So this might actually be pretty phenomenal. There's a little noise reduction there. Shows you a little bit more detail in there. This is the actual raw photo right here, and you can see some of the noise. And when you looking at it, when you take some of the noise out, okay, you can see the difference. You might say, well, why not use the one where you don't have all that noise? Well, what happens is, you see how that's like a double star right there? If we look at the other thing here, it gets a little muddy, and those files don't help. We get a lot of color blotchy over here that we don't really want. And by going to the raw files, which is what these are, you can see the nebula quite clearly. When you start to add this other compression algorithm in here that makes this noise go away, you start getting this color blotching, and you almost lose the nebula in the color blotch. But when you do it with a regular shot here, it's still there. Now it's looking better, and that's what we're going to do. That's what we do, Captain. So that's what we'll do. And so now we'll take another shot right now. Again, I'm just doing a few. Yes?
Ronald wants to know if the Cone Nebula fluff is from nearby stars.
The Cone Nebula fluff. I mean, you're talking about this white, this reddish stuff here?
He must.
Well, this reddish
Ronald,
stuff.
please clarify your questions. I'm doing my best, but there seems to be a bit of confusion. You didn't use the term fluff that I missed? No.
Yeah, I never.
Does something fluff off from stars when they die?
Maybe that's his term for it. But when stars supernova and whatever, they obliterate themselves and they spill their guts to the star stuff.
Yeah, that's not helpful.
It's
star fluff,
stuff.
that didn't really specify.
Well, star
fluff.
Yeah,
Come on,
star
Mark,
fluff.
Get with it. I thought you were an astronomer.
Yeah, right. Star fluff. No.
Talking over our heads. Don't use the technical term, Ronald. Break it down for us.
Yes, I mean, Carol got it right. Dryer lint.
Yeah.
Yeah, it's the dryer lint, Russ.
No, I don't think that's the same word that Mark uses. Isn't it like schluffs off or something?
Oh, okay. Yeah, no, that's slough, yeah.
Slough.
Think of it this way.
Slough, fluff, whatever.
Yeah, no, that's okay. But I get you, Ronald, now. And your answer, though, to answer your question, the answer is, yes. There is certainly going to be a amount of this material in here that is from the sloughed off, not fluffed off, but I get your point. The sloughed off material from these stars that bloated into big red giants. And then they were so big that the outer atmosphere is far, far away from the center of the star and the source of the center of gravity. So the slightest outward radiation pressure from that star is going to allow this stuff to slough off, or fluff off in Ronald terms. Okay? And that happens. And sometimes when it's red giants, it's this black, sooty material, dust. It's for other gas. And I think that it's really... it's really important to understand that that's only part of the answer. The other part of the answer is that this dark material has come from the previous supernova explosions from many, many millions and billions of other stars out there in the universe. And over time, it gets distributed to interstellar medium, not evenly either, in clumps. And those clumps make clumpy things, like galaxies and like stellar clusters within galaxies and spiral arms and so forth. So there's an awful lot going on here. All right. And it's really kind of fascinating. That's the early nebular shot that I took. I'm going to get rid of that.
What's your favorite quote by Carl Sagan? We are made of cotton candy.
We are made of star stuff.
And some of us are fluffier than others.
And some of you are indeed fluffier than others. Amanda, you are fluffy.
Thank you.
Daryl is not fluffy.
Oh.
I got naturally curly hair.
You got fluffy hair.
Yeah, so do I. I have my. I'm sort of channeling my inner. What's that guy's name? With the hair that goes up.
Bozo?
Hey, hey, kids.
Einstein?
No, singer.
A singer with fluffy hair?
Yeah, his hair goes up. Lyle Lovett. I'm channeling my inner Lyle Lovett.
Yeah,
Right?
that's who
This
I
guy,
was thinking.
right? That's like this. See? My hair can go way up there. You know, there it's my inner Lyle Lovett. You know. Family members looked at me earlier tonight and they said, are you gonna go on the air like that? I go, why? Your hair. I'm like, oh, I don't care. And I just went like that and said, look, it's fine now. You know?
I like Tara's question.
What Tara
Are
say?
fluffy stars higher in magnitude?
Our fluffy star. Oh man, I don't
How do
want
you
to.
measure fluffiness? Asks Marson.
Marson, there's no such quality such as fluffiness with the stars. And I'm pretty sure that there aren't any astronomers that would think there are. I'm just following Ronald's question here and just adding injecting a little humor into it. But really we're talking about material that is just leaving a star's surface because it's so big that it's not really being held by the star's gravity anymore, and the outward pressure of the radiation is enough to push it away. That's what happens with the biggest stars, the red giants. And usually those are going to go supernova and then explode their entire guts to the rest of the interstellar medium anyway. And that's cool. You know, I just can't wait to see a supernova. And no, our sun could never go supernova. Not at all. Because it's way too low mass to do that. You know?
Q had a question, but I'm not sure exactly what they mean. If they mean like the pictures on your camera, maybe?
I'd like to hear what
said,
you has to say. Bring him in here, number one.
They're saying, so is all the information that is stored in the original raw image just enhanced after using software like Topaz, or is it considered destructive to the pixel data?
Okay, that's an excellent question, and I'm glad you asked that, because that's what I have to deal with all the time. Who asked that question?
Q.
Q.
Welcome,
Okay.
Q.
Yeah. Here's how it works for me. In my workflow, when I take an image like this and I want to work on it, to process it, I mean, this is all very subtle data right here. It's very subtle data in this dark area right here, and then this up here, this area up here, this red. This is all very bright data, okay? The subtle data and the bright data have to peacefully coexist in the final product. But when you process these, you run a danger of getting rid of this dark area because it's going to be dimmed out by the processing here, which is going to brighten everything up, and then maybe this gets lost. So then when you look at the noise that we talked about, like here, okay, there's a lot of noise in here. I'm going to get rid of this noise, and what I do is I get rid of it in a way that isn't destructive to the original data. It actually is like lifting the veil that allows you to see the original data behind it. So I always look at this noise as sensor noise, and it's related to how much energy is falling on the sensor, light, okay? And so that noise will be exacerbated or made worse by higher or lower frequencies of light that hit the sensor. So if the light is dim, you'll get one type of noise. If the light is bright, you're going to get a different type of noise. The more light there is, then the better you can deal with the noise. But if there's lower light, then sometimes this data starts getting so faint that it starts to mingle with the noise. And now that's a problem point. You got to be careful when you start to pull data out when it's that dim. That's why what we do is we take all the images like we have been doing tonight, and we take many of them one after another, just like this, and then we come back later and we stack them together. By stacking them together, this stuff here, the stuff we want, we call that the signal, right, becomes dominant over the stuff we don't want, called the noise in here. And by adding them together and stacking them together, we take all these different modeled areas, which are going to look different on every frame, and we're going to then get rid of that modeling and be able to remove the noise. And the AI program, AI as an artificial intelligence program, will go through and scour the image and line by line, set of pixels by set of pixels, depending on what's bright near and what's dark. It'll remove selectively some of that noise. And that's the secret, getting rid of the noise but maintaining that data. So my goal is to maintain as much data as possible. Now, technically, this raw image is probably the best illustration of the data. Okay, so I'm going to alter that by doing processing and by stacking, and that doesn't sound too good sometimes. If you talk to people that work in astronomy, they'll say, well, I don't want to have anybody changing my data. I just want the raw data, whatever it is. Keep that raw data. And sometimes that's what they work with. So they will stick with, and they'll just say, okay, I'll deal with the noise, But that's not what I want to do. And I want to do images that are beautiful to look at, that actually show you what's going on in the universe. So if I was doing research, I would not be stacking any images. I would just be taking these images as individual data repositories, and then work on those. Especially, for instance, if I was doing exposures of stars in order to do photometry readings, where you study the brightness of the stars with that. So there's a lot of things you can do.
People are doing that with Hubble original files, are they not? I think they've been invited to try it. They take the original raw data and they remanipulate the images, they reprocess them, and come up with something different than how the original Hubble files were published by NASA and ESA, for instance.
Yeah. And
I mean, you still have your original files, don't you? You're working with copies, I assume.
Yeah, for sure. Yeah, I don't ever throw away any of the raw files. So you can imagine the size of my solid state drives and how many I have. I just bought 2 more terabyte solid state drives. Like, solid state drives, to those who don't know, you have hard drives in your computer, right? And they spin and they whir and they click sometimes. That's when it's bad. But solid state drives are like the SD cards that go in your camera, or the mini SD, those micro SDs, except they're on steroids. They're this big, and they can be used as whole hard drives. And so that's what I have. This whole computer we're running on, all solid state drives. Okay, there's like 5 solid state drives running this computer. And it's a very fast computer with a solid state drive as its core controller. So doing that allows you to have the fastest running computer, but it also gives you the capability of having the most reliable storage for your data that you can possibly have. I had what's called a RAID, right? And a RAID is a system meant to protect your data. Well, I had a RAID go bad, and it ruined all my data. Not recently, and not with astronomy. So what do you do when that happens? You try to find a better way. And you're always chasing your data. You're always trying to find another place to back up your data, save your data, back it up. And the sad part is, none of this is permanent. Even the solid state drives only have like a 10-year lifetime. And if I came back in 10 years to try and access some of these files, you might find that they're not there anymore, or that they're corrupted. And it's like never to come back. So you're always backing things up. And hopefully with the solid state drives, I don't have to back up as much or as frequently. Because honestly, I have, 1, 2, 3, 4. I have 5 computers running at all times. Okay, the one running this observatory is just one. There's one sitting here, which used to do that, but now is a backup repository. There's one behind me, which runs the 3D printer that's back there. And there's several in my shop, which run things like the laser cutter. And let's see, we've got the laser cutter in there. And I think I've only got one computer running in there right now. I used to have 3. So I have about 5 computers total. Now, and there's one out in the dome, too, as well. That's running all that stuff out there in the background. Actually, you're seeing it right here. This is everything you're seeing on the screen comes from that dome. All right, so let's. So, in other words, having that many computers means that you have that much data that can be lost. So, what I've done is every picture that's taken in SkyTour LiveStream is automatically going up to the cloud. Every single image, as it's being taken, goes up to the cloud. And it's no longer on any machine where it can be lost. So I also have storage that I buy up on the cloud, so that I can actually have all of my imagery stored up there. And then I bring it down and I operate on it, and then I store it on yet another SSD drive, pulling it back down from the cloud. So it's in many places at one time. So if I lose it in any one place, I still will have 2 other copies at least of it. Because, after all this work, you don't want to lose stuff, And you know how bad computers can be. Daryl certainly does.
I'm sorry.
You certainly know how
You
bad
were
computers
breaking
can
up
be.
on me. I'm not sure if Daryl heard that too.
Yeah, you're breaking up rather badly, Mark.
Yeah. That might be in Skype, but I don't know if it was breaking up on the way out. But I was just saying that I don't think that I think and you have had the experience where you're familiar with how bad computers can be to you.
Sure.
Yeah.
I've lost hard drives.
Yeah.
I have one external hard drive I back everything up to, and I've had those fail on me before. I don't trust the cloud. I don't believe in the cloud, so I don't use the cloud. But when it's gone, it's gone.
Yeah.
There's a writer for the Minneapolis newspaper named James Lilacs. Ronald might be familiar with him.
Okay.
I read his column pretty much daily, and backups are one of his bugaboos. That he backs up everything constantly. Backup on backup on backup.
Yeah.
And still it's evanescent. It will not be there forever.
That's correct.
I had a neighbor who was big time into computers, part of his job, and he ran, I think, 7 computers simultaneously in his house. One of them was a Sun server that he got hold of somehow, and endless backups.
Yeah. People try to stay ahead of it.
Yeah.
Now, I will say this. There is a better way. And that better way has to do with the SSD drives. And people will say, well, they're good, they're bad. And like I said, solid state drives are just big SD cards, just like in your camera. And you know that you've gone back to SD cards 5 and 6 years later and said, oh, what are those pictures? Holy cow, those are old. So I think that it's pretty pretty clear that the SSD is a better choice. I've had hard drives fail, you know, that spin, you know, the physical spinning hard drives. That's so much that can fail. So I don't rely on them anymore. So every computer system that we're using here in STLS, right, SkyTour LiveStream, is one of these solid-state systems. Can't be anything less. Just cannot.
I've never really understood how information put on a DVD can fail over time. You'd think that would be permanent, you know, if it's laser engraved or whatever.
Yeah.
But I know they say those things have a limited lifetime too.
Yeah, and that reason has to do with the way that the DVD writes on that emulsion, if you think of it that way.
I guess engraving is not the right word, but you know what I mean.
Yeah, I mean it's actually making little pits and mountains basically on these CCD writer, you know, the writers that are in the DVDs, and when they write this information, if you look at it microscopically, it's making, you know, it's got a profile to it, and over time that material will degrade, and so that's why DVDs won't last either. And I have a whole cabinet full of DVDs that I used to do this writing on, thinking, hey, these are the best things since sliced bread. And that was before SD cards, you know, and before SSDs. So now with SSDs, we have another new thing, which is the best thing since sliced bread. Until the next thing.
Well, think back to the good old days when Edison first came out with his. Would you even have called it a phonograph back then? He wrote on wax cylinders.
Oh yeah.
Those things were good for, you know, a very limited number of plays before they were wiped out.
Yep, that's right. And they are the best thing since sliced bread.
I don't think they even had sliced bread back then.
They were the best thing since French bread. French rolls or something. Yeah, that's pretty cool. You know, I thought this is something Martin Gardner, famous mathematician, he basically talked about if you had the technology and could write small enough, then, okay, this image is no good. If you had the technology and could write small enough, you could encode all the great works done by humans simply by making a single mark on a very, very precisely made cylinder of metal. And measuring the distance to that mark from each end gives you a number to a certain number of significant figures. And if you remember from your math, a significant figure is what comes after the decimal point. 2 significant figures is like 1.25. Okay, the 2, 5 are significant figures. Going to 3 significant figures, it's 2, 5, 3, or whatever, you know, whatever those numbers may be. Well, if you could actually measure it with enough accuracy, you could encode something that's like 1.25755536355, and basically that could end up becoming a literal code that gives you every single bit of data for all the great works we've ever done. And it was a really interesting discussion by Martin Gardner. I thought it was really cool. You know, it's the metal bar, what do you call it? I have the book. The book is called Gotcha, actually, and it's a really good book. Really, really good book. It's a puzzle book. It tells you don't have to do puzzles, but you get to learn about things that are really interesting. I used it when I was teaching physics classes. It was kind of fun. Yeah, I'd use one like at the conclusion of like every class. I would throw out a new Martin Gardner thing. It was cool. I did a few of my own. Yeah, it was fun, you know. I like I like these things that make people think, you know?
Definitely.
You know? I mean, like, how many of the people watching are going to be able to pass the Planetary Nebula test that they get next week from me?
Ooh.
Just kidding.
Making sure you guys are still awake out there.
Yeah, just kidding.
And wave of panic, pop quiz.
Yeah, hardly. No one's panicking here on that. You know. How many of you are watching this on your big screens, porting it to your TV, doing that screen sharing thing?
I saw someone post that they, them and their wife watch it on their big screen TV, but that was a while ago. I cannot remember who typed that now. Sorry.
It might have
Whoever
been.
you verify it.
Was it the woman that? Was it Rebecca that does the? She sang the theme for our radio show. I know her and Dan do
one,
it.
I didn't see her in here. Rebecca, hi. If you're in here, I'm sorry I missed you.
No,
No, I don't think it was her. I thought it was. I don't know who it was.
Yeah, I don't think Rebecca and Dan are here tonight, but that's okay. If they are, then I'd love to hear from them.
I was just thinking about our theme song the other day.
Were you?
Maybe a week or so ago. Yeah.
Yeah. I mean, I could play it on our show
beautiful
here,
song.
you know, but I don't. People don't get to hear the whole thing. You know, they only hear the little piece of it because, of course, it's not a radio station. It's a talk radio station. You know, Marston's watching it on a 2K monitor. Good. That's very cool.
I wonder. If we ever go to StreamYard with SkyTour Radio, we're going to need a little intro video with that song anyway. I know I made one a while ago using some of your images, Mark, as they'd pop up in the background, but again, we'd only need like 30 seconds or so, just the intro.
Oh, yeah. When we do the StreamYard thing?
If we go to StreamYard, yeah, we're going to have some kind of visual to link it to the audio. Some kind of little intro video until we go live, like the little countdown.
Yeah, I like it.
So there might be a new video coming up in the works, folks.
Yep.
If you guys have any idea of what that intro should be.
Well, it can be pretty clever, you know, because we like to do astronomy things, but you know, you might be fooled. There might be some stuff in there that's like, wow, that's pretty cool, you know.
Usually it's, you know, maybe some kind of basic banner. iDetective has a really cool one, a whole bunch of footage of cops in action and stuff, but
with some music and stuff, I imagine, right?
I'm trying to think for Jill's show Friday night and QP Science Friday at 10 Eastern, and the Chris DiPerno show Project Aries on Saturday night at 7 p.m. Eastern. They, I think, just have their like little banners, just the show name and picture of them and the time and everything like that.
Okay.
We can do much better.
Oh, yes.
We can do much better with ours.
Yeah. I think we can. Trying to figure out what this little line is right here. If that's an artifact of the photo, we'll see. Let's look on the previous one. It's not there. On this one it is. You see what I'm talking about right there, Daryl? See that?
Yes.
I wonder what that is. That's clever. Clever little fellow. It's a clever little fellow, Brian. Let's see what it is. Hey, Rachel, how are you? Rachel Sobek is in the house. Okay. Okay, I'm just about done with the this nebula. Ready to move on. Do one more. Okay. What's that? What? I'm not. What? I don't know what you mean. I heard some clicking. I don't know what that was.
I said it's quiet. A
Oh.
little too quiet.
The clicking was me, sorry.
Oh no, no worries.
The clicking was time.
Yes.
winding Down.
Yeah.
The clicking was me trimming a fingernail.
Oh.
Sorry.
Astronomers are so prim and proper.
Maybe so. Okay, let's make sure we're in. I gotta get out of my exposure first. And then we'll go to measure 47 in Puppis. Okay. Here it comes. Alright, well there is our last exposure, and I have enough with which I can do a number of things. I did dark frames already, Daryl, which are done ahead of all this. So we have dark frames already for this set of exposures, and we should be able to come through and do something crazy with that in just a couple of hours.
Cool.
As I said, they're all these photos are now up on the cloud. None of them are stored on the computer out there. They're all up in the cloud, which is good. I know you don't do the cloud, Daryl, but for me, they go to the cloud as soon as they're taken. So when they're out in Arizona, I'm not going to have to connect to that computer and download them. I'm just going to already just go to the cloud online and pull them down from there. Which is obviously a better workflow for that. Okay, so now let's go back over to our amazing main screen here, and we have M46 and we have M47. Is it M46 that has the? I think M46 is the one, doesn't it? That has the Planetary Nebula in it. M46 or M47?
I think it's M46.
It is, you're right, because there it is right there. Okay, we're just going to go to M46 now, and I'm going to show you guys what's going on here. Daryl, can you put that mute on?
I'm sorry?
Can you mute?
Do you want me to?
Well, only when, you're doing that.
Sorry, it's late. I'm tired. I forgot to mute.
No worries. Okay, we should be...
Oh, I'm sure you hear clicking for me typing all the time when I forget to mute.
Well, I do the
But
same.
you never hear me talking when I reply when I forget to unmute. Fancy that.
Well, that's true, I'm not sure if we already came over here or not. Okay, let me just take a quick shot here, and we'll do 15 seconds here. I actually didn't see if the telescope went to this location yet. I have to just see right now.
Okay, I might mispronounce this name, but Genghis wants to know if you know Tamitha Skov? S-K-O-V.
Oh,
Says she shares great info on space weather.
I do not know her, but we're at the right place. Look at that, Daryl. I mean, we got a dome issue, unfortunately.
For
Yeah,
those of you who
fluff.
like pink.
Yeah, that's the dome.
Fluff should be pink.
Yeah, right.
Ronald, this is star fluff. No, I'm just kidding. All right, let me go move the dome, because this is really a beautiful cluster to look at. All right, I'll be right back.
Okay.
Okay.
This is, as opposed to dark matter, this is pink matter. Probably always on the hunt for the elusive pink hole. So what's this? Just because I know when he hits the dome, it's usually a lot more red. I don't know what this pink is.
I would assume it's the dome. It might be clouds. But I wouldn't think you would have gotten a very crisp image with this, which this appears to be. We'll find out here shortly.
Yeah. Especially when he thinks he's near the dome, we usually see it just on the edge, not the entire thing. So this is really bright on the eyes. I don't know if anyone else is almost going blind here, but this is a pretty intense color.
I'm sorry, I'm not very talkative.
I know, me neither.
I'm afraid my clock is winding down for tonight.
Uh-oh. Well, I'm not sure if we're doing a show on Sunday. I assume we are. Are you going to be joining us, I hope?
I don't know. I haven't heard anything about it. If so, what the subject matter would be.
I see Mark is back on screen. Are we a go for Sunday, Mark?
I believe so. I haven't written the show yet, but
Okay.
I have to come up with some ideas. If you guys have some ideas, I'd be happy to entertain them.
Yeah, Carol posted a link to that lady, and Genghis is saying that she might be a pretty cool guest to get. We don't usually have guests on our show, but you know, that's not to say it's an absolute no. We never have guests. It just never came up as of yet.
That's true.
Something to consider, though, Mark. Either, if not even on the Sunday show, even here, where we have a little more free time if the conversation gets good, you know?
Yeah. I actually, I had Commander Cobra on one of our first live streams, actually. He came out with me. We talked for a while, if you remember. Remember that? Were you with us that time? You were with us, I think. Wow.
Possibly.
So this is...
I assume the dome was the problem.
You got it. The dome was the problem. So you can see, we just did a quick shot here to show. I did a quick shot to just show that. But I'm going to move it over just a little bit. And then I'm going to let it reacquire its guide star. And then we're going to actually go up to 12,800. We're going to go to 30 seconds. So it's several stops photographically. And the reason we're doing that is because I want you to be able to see some of the color in that Planetarium Nebula. Right now it kind of looks black and white. And that's not exciting. Not as exciting. The color in this nebula here should be kind of the greenish blue of the O3, the ionized oxygen, and there's a rim of red around the outside edge. Really, really stunning. Now, that cluster you see there, that's the cluster that's 4,000 plus light years away. But this star, with this planetary nebula, this is only about 2,000, just a little over 2,000 light years away. But because it's superimposed, okay, look at that. It looks as if it's in it, and it actually was quite puzzling to astronomers for a long time until they could figure out how far away that was. But you can see that red tinge around the outside edge. That could be hydrogen alpha, or the H2 as we talk about, the ionized hydrogen. That could also be neon, and there's a few other elements that might be in this stellar envelope. But notice what happens. There in the center is this star. Okay, that's actually a white dwarf in the middle. Okay, the remnant of what was formerly a star. And then there's what appears to be nothing and then this outer envelope. This is an example of a planetary nebula where the star sloughed off its outer layers and then stopped sloughing off its outer layers. And maybe that's because it collapsed rather abruptly, who knows. And it made a rather interesting void in the middle here. But it's not the only place we see this. The Ring Nebula has that same thing. The Helix has that same thing. The Dumbbell Nebula does not. Okay? The Little Dumbbell, measures 76, does not have that. They're a very different type of nebula. This is probably, as I've talked about, a spherical shell. And if you look at my hands here, on the edges you can't see through my fingers, but on the outs, on the front and the back, you can. So when you look through my fingers, that represents a thinner material you're looking through. Around the edges, though, it's thicker, and around the back, it's not, and you can see through that as well. So that's kind of what we're looking at with these spherical planetary nebulae, okay? But that sharp border, there's a really sharp border that shows that process, something stopped along the way that makes that border more sharp. Now, maybe with higher magnification, maybe with a better view, we could detect what's really going on in that center and maybe see that there's more stuff in there than we recognize right now. But I don't know. I'm going to drop this. I'm going to come up 2 more stops, go to 20,000, and do another 30-second shot. There'll be a point where we'll start to see even more color. You can see the color here. In this previous shot, it looks almost black and white. You really can see a little bit, but not a lot of the color. We can see more color in this one. And now in this last exposure, we'll be able to see the full reach of the color. If it's there, it'll show up. I suspect it's going to be just a little bit more colorful than this one. Yeah, now you can see it really clearly. Look at that. That's really pretty. Okay, so now a little image processing. So now you can see the extent. Now it kind of looks like the Ring Nebula, doesn't it? It like the Ring Nebula that we see in the constellation Lyra. Okay, and similar thing. And now we can see some detail in here. Really interesting. I wish I could. I wish we could operate on this, image process this a little bit more dynamically, but we can't right now. So I went out there and the grass is frozen, so that's showing it's getting pretty cold out there. Luckily, I do have heaters on the telescope to keep the optics clear. They're just very, very gentle heaters. They keep the temperature just a degree above freezing, so we don't get any of that frost forming on the telescope, because it's a big piece of glass and on the front, and any moist air that falls on that could technically cause a little bit of icing up, and we've had that in the past. And then I got the heater and we don't have it anymore. But there you go. There is this beautiful planetary nebula, somewhat apparently in this cluster of young stars, and clearly it's not really. All right, so that's Messier 46. Daryl, if you wanted to add anything, feel free.
No.
Okay.
I am running out of steam here, Mark and Amanda. I think I'm going to call it a night, if you'll excuse me.
All right, Daryl. Thank you for
joining us, Daryl.
Well, thank you for joining us, Amanda.
Always fun hanging with you on a nice, clear evening.
Same here. Same with you. Everything's better with Amanda.
Yep.
Oh, thank you.
Very true.
Oh, sure. Okay, well, I'm going to call it a night then. Y'all take care and have fun. And
okay, Daryl.
See ya. Bye, everybody.
Rest well.
Okay.
Bye.
We'll talk to you soon, Daryl. See you later.
Bye-bye.
Oh, and it looks like Martian is going to bed now, too.
Okay. Thank you very much for coming out, Martian, and hanging with us for a while. I really enjoy having you guys come and visit with us. Okay.
And for those that are new to the channel, do consider subscribing and hitting that bell for notifications. Unfortunately, a show like this, we can't really say we're going to be on Tuesday at 9 because if the weather doesn't cooperate or Mark gets busy, it's kind of when we have a clear sky, we take the chance. So
Yeah.
it's better that way. Just get a random notification than ever try to time for it because you know what happens when you make plans, right?
Yeah. Best laid plans end up
Mm-hmm.
being a problem. Yeah. Ooh, look at that. That's cool. Do you see this little nebula right here? Look at that, huh?
I do.
That's the Butterfly Nebula. That is so neat. I've never seen that here. So we're going to bring that in and check it out a little bit closer. That's really pretty. It's another planetary nebula like the one we just saw, but it's actually one that I've actually never viewed before. I am so happy to see that.
Very cool.
Yeah. I'll go to 30 seconds on this at 25,600 too. There might be more detail out there that we're missing.
Oh, fingers crossed, guys.
Yeah.
Keep your fingers crossed for 30 seconds.
Hey, Adam Lorber, how are you? Are you saying bye because you're leaving?
I think he's saying goodbye to Isabella.
Oh, Isabella.
I hope. If not, goodbye, Adam. But I think he just got here.
Okay, Isabella, good night. Thank you for coming.
And Marcin's off to bed as well.
Yep, Marcin, good night. Okay, we're doing this 30 seconds now. We'll see what happens. But look at that. That is really just a little spectacular little nebula right there.
Very pretty.
Yes, I appreciate my nebulas. Let me get out of the way here. Oh, look at this, man. That's just a beauty. Huh. Kind of interesting. I would like to look that one up at some point and see what we're looking at. I definitely can see some hydrogen alpha in there. You can see some red in here. Very, very heavy duty red, actually. And then there's like a blue up there, which is kind of cool. That might be some type of scattering nebula up there, maybe. But that's so cool. That's neat. And let's see now. Let's see, Albino Butterfly Nebula. Boy, what kind of names are those? Wow. Yeah. Aye, and there's the Skull and Crossbones Nebula, Captain. We'll try that one too. Off we go to the Skull and Crossbones. Perhaps.
We were just looking at nice Christmas trees and butterflies, and now you're bringing us to the Skull and Crossbones.
Aye. What's wrong with that?
Stream's getting dark, folks. Hold on to your hats.
No, it's not getting dark. Just want to see the Skull and Crossbones. Why not?
Well, I guess the people that were getting tired left at the right time. Don't have nightmares.
So, huh? Nah. Oh, cool. I'm glad you're still here, Adam.
He was asking if our Sunday show was on YouTube, and I said, not yet.
Yeah, no.
What is the holdup on that, by the way? I mean, I know you were busy filming the last few weeks, but Daryl has a camera now, and I'm not planning on being on camera, but I can get into StreamYard, so...
We're not going to do it unless you're on camera. You must,
oh, really?
You must be on camera, or we're not doing it.
Really?
If I say yes, will you get your camera?
No. I'll just tell people that we're not going to be going to YouTube.
Oh, listen to you. So, how about that, folks? No one gets to see the YouTube version because Amanda doesn't want to be seen on camera. And she has nothing to worry about. She's a pretty girl. I don't know why she doesn't want to be seen on camera.
Thank you. I appreciate that, but I have trouble hiding my expressions, and people will know what I'm thinking at all times as things happen, and that probably wouldn't be good for the station. So, plus, I mean, if we are on StreamYard, that means we'll be able to have pictures and videos and stuff like that
I'll be busy doing that. And as always, I'm always keeping an eye on chat. So
Yes.
you just watch me. Like, I'm not going to be making eye contact with the camera looking at the people. I'm going to be distracted and reading and hitting buttons and off screen. And
There's nothing wrong with
it's
that.
just going to be a distraction. It's not going to happen. Let's just leave it at that. It's not going to happen. But thank you. I
Okay.
have enough anxiety issues. I don't want to be on camera.
Ay. Okay.
You're the one that loves the camera. You've had all sorts of TV and film experience, so.
But that doesn't. I mean, it's not like you love the camera. It's not like I love the camera. It's like I can't wait for my next appearance, Mr. DeMille. I'm not that way. I'm okay with it because it seems to be the medium by which I can get my astronomy out there and my expertise, that's all. If that was by greeting cards, that's what it would have been. If it was by I don't know, if it was by cartoons, that's what it would have been, and I'd be okay with that too. So it's all right. It's just that's the best medium for me to get astronomy out there and get my expertise
definitely.
out there.
Yeah. Yeah, well, all the things I can do can be done behind the camera, so.
Maybe. We're taking this picture. This is the Skull and Crossbones Nebula right here. And every one of these nebulas generally starts with a cluster of some kind. And this may be the cluster in the Skull and Crossbones. I moved it over here, by the way, so it's a little closer. All right, and you can see that it looks pretty interesting. And this is a 30-second shot. And what I might do is just change us to filter narrowband 1, which is a slightly tighter narrowband. So we'll do that, and we'll go up to 51,000 or 40,000 is good, and then add for a minute and see what we get. So once again, here is the Skull and Crossbones, and you're gonna ask, where is the Skull and Crossbones, right?
That would be the logical question.
Yeah, I can't really help you with that because I don't know. I don't know what a Skull and Crossbones is. I just don't. What can I tell
He's
you?
lost the nebula, folks.
Huh?
Is it a nebula?
Yeah, it's a Skull and Crossbones Nebula. It's actually about this big. You can see some of that. But with this other, with a narrowband filter, we might be able to see a little bit more. That this bright area, again, this is down kind of low near the horizon right now, so we're seeing it looks a little bit brighter. That's more like it. Okay, that's more like what we should see. Okay, see, that's how the filter works. See that? Isn't that incredible?
Yeah.
Yeah.
It's gorgeous.
Yeah, that's beautiful. Wow.
It's funny, such dark recesses of space have such vibrant colors.
Isn't that true?
And,
Here's what the nebula looks like with just the other filter. That's a narrowband filter, but it's a wider pass through those special band passes that we look at. And then this, boom. I mean, look at the difference. Look at the difference. It's almost worth doing a couple of these, I have to tell you, I stacked 4 the other day, and it was actually quite beautiful. The stack came out pretty nice.
I bet.
Yeah. All right, so let me.
And on that note, I'll go find our Facebook link because you guys can see the raw and stacked images.
Oh yeah.
In our Facebook group.
Yeah.
And if you like the raw images, you can download them yourselves and play around with them, see what kind of creations you guys come up with.
And if there's any that you want, just let me know, and if I didn't put the raw up there, I will. I'll give them to you. I don't have any problem with sharing this with you, and I have no problem with you guys having some fun yourselves. And if you want to know how to do it, then there'll be more like the other night's stream when we thought we were going to have a clear night. And I ended up showing you some image processing with Photoshop and everything. And there's other ways to do that without the expense of Photoshop. But again, Photoshop is $10 a month, and you get the latest version of Photoshop. It's really beautiful. Okay, there's the next one. Wow, this is...
And if people do take images and play around with them, if you want to share them back with us,
yeah, that would be nice.
Once you're included in the group, you can post some images that you've created or even captured yourself if you guys do this on your own.
Yeah, exactly.
I want to share it with the community. Please feel free.
Yeah, feel free. We'd like to see it.
Mm-hmm. I know a few friends of ours, Carol being one of them, really.
We know
there's
Carol.
Anything of interest going on in the space community, they definitely post links for us.
Mm-hmm.
Keep up to date with all the happenings.
That's right. Mm-hmm. That's right.
It's too bad. You know that thing you have where it puts up the images of like the zodiac signs and like the really big constellations and stuff?
You mean,
it's too bad they didn't do that for everything, like nebulas and stuff.
You mean
So you
Stellarium?
can see the skull and crossbow. Yeah, is it Stellarium?
Oh, yeah. Okay, so when you go in the Stellarium, you see the skull and crossbones. You can see this is the nebula. Now, why does it look like a skull and crossbones? I don't know. None of us can see it.
Adam says if you look it up on Google, you can see the skull.
Really?
Mm-hmm.
Okay. Thanks, Adam.
I mean, I find with this, I wish I could see all these images. I can't. I try.
I can't either. It's
I can
not
never
just
see
you.
anything.
It's not
That's what
just
to
you.
say.
It's not just you.
And then it's kind of disappointing because it's like Gemini are supposed to be the twins, but they're just two stars. It's kind of disappointing when you're looking for like full bodies, arms and legs, and
Actually, Gemini is one of those few constellations where you can see that. Because you have to know where to look in Gemini.
I never know where to
God,
look.
this is beautiful. Sorry, folks, but I'm going to be taking some images because I would like very much for you guys to see this processed.
See, you guys have the skilled eye. Like, you were looking at the Christmas tree nebula, and Daryl's like, oh, you pointed out that it's upside down, right? I wouldn't have known. Never in a million years. I'd just be trying to make up, like,
Yeah.
the closest thing I can get to a tree, you know? Like, and everyone can see faces with the pareidolia. Everyone can see faces in anything else they can't make sense out
That's
of.
right.
So, skull and crossbones seem logical.
Yeah.
Surprised there's not more faces in space.
Yeah. Well, there's a face on Mars, isn't there?
Yeah, in Sidonia.
Yeah, well.
But who put it there? That's the question.
Pareidolia put it there.
Oh, come on. You're no fun.
I know. It's just a regular hill.
And I guess it's the same. Now, am I right to assume this? Is that the same problem we have with why can't we see where the flag is on the moon? Is that why we can't see Sidonia on Mars? It's just too far away for such a small little place?
Oh, I see what you mean.
Yeah.
Yeah.
Like, if we
the
could
hill,
look at Mars right now with your scope, but we couldn't see
No.
that detail. We couldn't see Sidonia now.
No, it's too far away, and Mars can, easily hide that from us because it rotates. Mars might be rotated away from us, and it's such a small location on the surface that even the Hubble Space Telescope couldn't see it. So, that's unfortunate. Yeah.
Is it? I might be confusing the name of it. I think it's the JPL that we're all waiting on for years and years and years. Any word on that?
JPL.
Or am I confusing it? What telescope have we been waiting on for
yes.
like
The James Webb.
the James Webb? Sorry,
Yes,
James
yes.
Webb. Any word on that as of late? Has anyone heard anything recently?
I don't have any information. Maybe someone else does.
Anyone in chat? Yeah, I mean, it comes up from time to time, and
It
they
does.
tell us why it's been delayed yet again. But I haven't heard anything in a while. Not that I've been looking, but
I
it
think
usually comes up.
I
every few
think we're
months.
going to be looking at a potential launch of this thing, and I'm hoping that SpaceX launches it because they have a proven record of success.
Very cool.
Yes, Carol, the James Webb. Yep.
You
Yeah.
said you expect it to launch. Well, that's the hope. Any idea when?
No.
That's gonna be
They
a
said-
tense moment.
They said this coming year.
2021.
They said 2020, and they said 2019. Yeah. You know what?
If they said this coming year back in January, then yeah,
Yeah.
it's gonna be an exciting time. It's gonna be a tense moment.
Oh,
No man, you think like
yes.
normal launches are heavy duty. This is gonna be massive.
Well, we talked about.
And the sad thing is, I don't even see it getting much coverage. Like people like you and like if it's SpaceX or NASA or what's that other one? Sloosh? I don't know. There's another one that
Slew?
does all these.
Slew.
Yeah.
Yeah, I was a Slew member way in the beginning as well.
I think I've checked out a few of their videos in the past. Yeah.
Well, actually, they were the group that originally had the remote telescopes that you use originally. And so I would use remote telescopes in the Canary Islands and in Australia and Chile. And the trouble is that it's just canned. You can only take, if you say I want to take an exposure of this particular object, you can do that, but it's only going to be a 5-minute exposure or a 10-minute exposure, and it's only going to be in the way that they choose to do it. You can't determine which filter you're going to use. You can't do any of that. You just have to do what they say. Yes, Carol Slew, that's what I'm talking about. Yep, that's right.
Yeah. People are saying October 2021.
Yeah, and that's
Latest date.
supposedly. And let's
Don't hold your breath, but it's something. I mean,
look at it. I'd rather it be done right.
exactly.
I'd rather it be done
You can't
right.
repair it once it's out there.
No.
Well,
You can just.
maybe you can, depending on what's wrong with it, but it's not like we can send someone out there,
Yeah, that won't happen.
On-call
That's it.
repairmen to
That's right.
outer space.
That'd be
a good B movie.
Yeah, right?
It's a good title, eh?
Yeah. I like that. Carol Carl has got all kinds of little quips tonight. What's going on there, Carol?
She posts more links to helpful articles than anyone. She's awesome. Thank you, Carol.
She's wonderful.
These are things I should be doing, but
Yeah.
I'm not. That's what I said. I mean, I could have looked this up myself. It's just, I just kind of thought about it now. I don't know.
Well, you used to do that stuff, but now because you're more busy, you don't do it anymore.
Alright, who sent me all the articles for last week's show?
No. For SkyTour Radio, you do plenty. But I'm saying for SkyTour LiveStream, you used to put those links in, stuff. But you don't do that. But that's because you're so busy, and I'm very pleased that you're able to join us at all.
I got to talk with all my friends in the chat room.
That's right.
That's
you
just
do.
keeping me busy.
Yes, that's fine.
No, well, I don't know. I wasn't really thinking about it until you said something, and then it made me think of it, and I just started talking about it before I actually bothered looking it up. But I would have. But you guys are awesome, so
Yeah,
just know you have my back.
these are great people.
They are great people.
Yep.
I love these people.
These people love you.
Ah.
You know that's true.
Ah, that's nice.
You
I
know
hope
they
so.
love you. You know they love you.
Oh, my slacking ways, they haven't all forgotten about me.
No, they haven't forgotten about you. In spite of that, no, they don't. They're not.
Nice.
They're not forgetting you. See, look, here are the Gemini twins. This is why I think these look like twins. Okay. There's Castor and there's Pollux. It looks like they're standing arm in arm, and there's their legs, right?
Okay.
Yeah.
But how do we see that without the little stick figures?
Well, without the little stick figures, it looks like this. Okay. You see 2 stars here, you see 2 stars here, and you see 2 stars here. You see the logical twin there and there. You can see that in the sky. That's what you see in the sky. Okay. You don't see that, no, but you do see this. And so you see the logical stick figures, which is interesting. And then I want to look right down here. Actually, at this cluster, and we're gonna go check it out. And while we're doing that, I also want to make sure that we go back to Narrowband 2. So we're going to Narrowband 2 right now. First, we're going to a star that gives us the location and direction. So this is our star that the telescope is going to first. We're using high precision pointing. So you'll see this star sits there, and then boom, it's gone. And it's gone because we're going to be bringing in another star. Shouldn't be doing that. We're going to be trying to find the that's moving into a position, and we should get to the cluster right from there. So I'm waiting for that. So that's going to go. That's typically what it does. And it's centering up in the guider, and then away it goes. And it should now go to our cluster. And let's see if it did.
And while you're looking,
I believe it did. There it is.
Right, I'll be right back.
Okay. All right. Now let's give it a chance and see if it's done anything for us. Let's go check it out. And we'll just do a quick 20-second exposure at 40,000. Yes. Hey there, Amanda Shaw. How are you? I like your aliens, Amanda. That's very cool. Alright, let's see what we got now. Alright, I think the dome probably blocked it. We're gonna find it. Let's do a quick 20 seconds. It probably won't be focused. It'll probably be streaked is what I'm saying, but I just want to see where it was. Oh yeah, I believe the dome is being blocked. Oh boy. Yeah, see what happens. Let me see if I can show this to you. Let's go back to our original scene here. Okay, and I'll show you the dome cam. Alright, so now, okay, here is the telescope as we see it, right? You see the telescope right here. Now, what's also going on is there's a guide scope here. The guide scope's on the far side. And it's a cylinder, a telescope that sits right about here on the back of the telescope, okay, on the other side. But then on top of that, there's yet another telescope. And that other telescope is another guider, but see this part of the dome? With this up so high, it's looking at this. The guide scope on the backside is actually staring at this part of the dome. And whereas we see black sky, black starlight, black sky rather with stars, the guider can't see the stars at all. So it can't find the objects it was looking for. So we don't have that now in our view, and it's because of that. So let me see if I can find it a different way. Let's go and see if we can get to the Monkey Head Nebula.
Monkey head.
Yeah, let's try that.
What about the beetle head?
Huh? Let's see if we can get to the
These are
Monkey
good,
Head,
folks.
and we'll try that. Okay. And if we can't, we can't. The telescope might be getting blocked. Okay, well, we're gonna try it. See if this is where it is. We should be seeing just one star in the Monkey Head. And that might be it right there. We'll find out. Alright. We should be here.
Does
and
that one star represent the head?
No. The nebula represents the head. But let's just do 20 seconds at 40,000 just to see if it's here. This will tell me whether, because we tried to do something further north and it didn't get it at all because the guide scope was being blocked by part of the dome. So I came to something a little bit south more, and let's see if that finds it. If it finds this, then we can explore the Monkey Head. Let's see what we got. Yeah, it doesn't look like it found the Monkey Head either. The Monkey Head would be pretty obvious. Okay, so it's because the dome is blocking that. I cannot wait to just get rid of the dome and convert this to a roll-off roof, because then nothing will be erroneous anymore. Let me go to the east a little bit here. And I know I'm not waiting for the guide star. I'm just trying to do a 20-second shot to see if there's any nebulous characteristics here, because the guider couldn't guide properly. So it's very likely that it didn't find it, and it's not going to be in the nebula area. But that's okay.
Why is the guiding system not working?
Oh,
Is the dome's in the way?
Yes, because if you look at this, image over here, right? Let's just bring that right there. So here's the barrel of the telescope right here. Can you see that?
Yeah.
Okay, here's the barrel of the scope. Okay, on the far side, right about here, on the far side, is another telescope. That's a guide telescope. And then on the far side of that is yet another telescope sitting up above it. So it's a really odd contraption, and it ends up being in the way. This is when the scope is parked, this is the cover attached to a motor that I put in there and programmed. So as soon as the telescope parks, this cover can close and cap the telescope for me. So in Arizona, it would keep all the dust and everything out, because that's a foam rubber cap.
And sometimes, every once in a while, Mark will make this part of the screen full and show us him actually shutting everything down for the night. Not
Yeah.
always, but from time to time he does when it's not too cold out and he doesn't mind being out there.
Oh yeah, that's true. I mean, I might do that tonight.
Pretty cool.
Yeah, in fact, maybe now is a good time to do that because we've been 3 hours 30 minutes into this. That's probably a good time, yeah.
Yeah.
Okay. Well, that's what we'll
Unless
do.
there's just one more, D'Antonio.
Yeah, I know. That's usually what I do, but I think that we have to just wait a little longer. Yeah, I don't think so. There's
Don't
more.
think so what?
There's more I want to do, but I would have to actually move the dome to see it. I'd like to show people the Crab Nebula, for instance, but I might have to move the dome. I can try it. Let's see if I can see the crab. One more. Maybe, if it works.
And the Crab Nebula has nothing to do with Cancer.
No.
The zodiac sign Cancer.
No.
It's a crab.
Correct. It's not. The Crab Nebula, given that name, because it happens to look like a crab, but it's really a supernova remnant.
Fancy.
Let's see. Well, maybe. I'm not sure if the telescope. It might have found it. Maybe not. It depends. Again, that guide telescope looks like it's pretty high up there. I'm not sure it's going to be able to see it. I'm sure it's in the way, but let's just do a 25-second at 40,000 shot just to see. Just to see if we can see any of that, but the guider seems to be occluded by the dome. Although it might have been just enough to be able to see it. We have to see. Oh, this is unfortunate because, oh, look at that. How about it? It was perfect. It worked. Look at that. There's the Crab Nebula. It's really quite spectacular. Yeah, quite spectacular. That actually has filaments in it. You can see. Let me. I hate to take you away from it after you spent all this time to see it, but I'm going to take us to 30 seconds and go up to 51,200. So up 2 stops. Then we're going to try with the other filter as well. Okay, there it is. That red glow along the bottom is not the sunset. That's actually the sensor being affected by the amplifier noise that's right near the sensor in the camera. Look at that. You can see these filamentary structures in here. They're beautiful. Wow. And that is with our second narrowband filter. Now I'm going to come back to the first one and take the same shot, 30 seconds at 51,200, to see how much of that nebula can be seen, that supernova remnant can be seen with that particular filter. In other words, that would tell us how much oxygen 3, sulfur 2, and hydrogen alpha is in that nebula. Because those are the 3 things that filter looks at primarily. Now look at that. Is that not an amazing scene? You can actually see these filaments very clearly. I have to tell you, that's a spectacular scene. I have never seen these filaments in this telescope like this before.
It's pretty cool looking.
Yeah. So you can see some of them here.
A cell or something.
Okay. But then these, look at that. They show up so brightly. Oh, yes. Now we have to do some more. Darn you guys. It's all your fault. I do this all because of you. It's all your fault. Tara says, yay, we've got crabs. What? Just one. Wow. That's really something. These filaments are usually elusive, actually. And for them to show up like this means that we've got quite a good showing here. Look at that. Wow. You see those dots? That's the raw photo. This is the somewhat processed photo. We never ever stack these because these have already been data compromised because of the algorithm that gets rid of the noise in this one. It's not AI. It doesn't do it smartly. It just does it generally. This has more detail in it when we do this. Oh man, that's just an amazing image.
It looks like a cell or something. Like
It does, doesn't it?
when you're doing like that imaging and you put the dye in and it scatters all through the vessels and stuff.
Yeah.
Yeah. Very cool.
I'm glad that we can see it. I did not expect that we could see it. I didn't think that the telescope, in other words, was going to find it because of the way the dome was. So we must have just been looking through a tiny little hole in that thing. Ronald, time to sleep. Away you go. Boy. Again, never seen it like that.
Bad. Okay, good night, Ronald. See you tomorrow for Music with a Theme.
Doesn't music always have a theme? Wow.
Ooh, you'll have to tune in and find out.
Look at that. That is just spectaculario. One more there, and then we'll call that one quits. I can stack those. Probably should take about 3 more shots with the other filter as well. That's just amazing. This will give me something to shoot for later. This will be the kind of shot that will give me an idea of whether I'm going to come back to this Crab Nebula. By the way, this has a supernova, the supernova remnant of this is a pulsar in the center. And the pulsar is a rapidly spinning neutron star. And it has like a lighthouse beacon of hot radiation. And every time it turns toward us, it goes, psh, and kind of sends out radiation toward us. Psh, psh, every time it rotates around. Psh, right? And that rotates around once. Are you ready for this? It goes once around every 33rd of a second. So, in other words,
Wow.
it's rotating 33 times per second. That is fast. And that's a star that's the remnant of the star is the size of around Manhattan Island, maybe a little bigger in length as the diameter. So that's the remnant of that star. Okay, let me take us now and grab that was a beautiful set of shots, my gosh. Okay, narrowband 2. I'll just take another photo right there. And that's gonna look more like this one over here that we did right there. This will get us a lot of the general stuff, the general scene. But these other guys, we're gonna have like 3 or 4 of these to stack. We'll see how those turn out. Here we go. Beautiful. And I'll just move that one up a little bit. Take another shot. We wait the obligatory 11 seconds for the telescope to lock on. And off we go.
Q wants to know if it's 33 times per second at the distances it is away from us. What would it be like if you were up close to it? Do we know?
It would still be 33 times per second. That's the rotation rate that it's blasting out to the universe. And the only thing that changes between here and there is the frequency of the light might be altered slightly and because of the fact that as the light travels through space, it goes through other intervening material, and that other intervening material can cause the light to be sent a little bit lower in frequency. It's very high frequency as it is now, but it can be dropped a little bit lower by something called extinction and interstellar reddening. We noticed that there's lots of dust in space. Many of the images we took earlier that we looked at showed us this dust and this amazing panoply of dust that's out there. So when we look at objects that have dust in them, kind of like this one, this was the Rosette Nebula we saw earlier. Look at this dark dust lane. There's lots of dust in here, right? Well, that's the kind of thing that is also going to be present in the interstellar medium between us and the objects out there. And so between us and this guy, we might have some dust between us, and it might redden the light a little bit. And it's just incredible, So we would see that, we would see that happening, and we'd be able to detect that. I've got to check. I'm not sure.
Are you answering Amanda's question?
Amanda Shaw?
Yeah. Is that what you were just saying?
No, I was actually still answering the other question from Q.
Oh, okay.
Yeah, but I'll answer Amanda's question too in a moment. So just to finish up with Q, we know that the rotation rate we see from the Earth will be the rotation rate we see there. That won't change. Just the frequency of the light might, because of reddening and that extinction I was talking about, interstellar reddening. And that might be measurable. It might, I don't know if we have a good measure of that. We must have. We know how pulsars act and what their temperatures generally are. But they are very high frequency, and a lot of that can get through much of that stuff pretty well. Now, what was Amanda's question?
She just said, if light travels around the world 7 times a second, then how can we see 33rd of a second?
Oh, okay.
33 times a second be seen.
Okay, that's just... Okay, the light traveling around the world 7 times in a second is the illustration of how fast light travels. Okay? That's light. Here, we're talking about a physical object, a remnant of a star. And it's spinning so fast that it's spinning 33 times per second. And it has on its surface this pulsar, this remaining neutron star with these hot spots of radiation. It's like a lighthouse beacon. As it spins, if those lighthouse beacons are toward us, then we'll get a blast of radiation that we see as light from this thing, and we see them we see it 33 times per second. So we're actually watching these beacons pass us. All right. So one is the speed of light goes so fast that it goes around the Earth once in 7. If you could measure it and put up mirrors all the way around the Earth and angle them just so that a beam would go around the Earth, you'd get it hitting the return mirror 7 times in a second. Okay, and at that speed that light travels, it still takes over 4 years for the light to get here from the nearest star. That is an illustration of how big the universe is. It really is.
Cool. I hope that helps.
Yeah.
I heard you talking about numbers and distance and stuff, so I
Yeah.
wasn't sure if you were addressing her question in there or if
it's
if
okay.
it tied in. So
No, that's fine.
just didn't want to miss my cue.
Yeah, that's fine. All right. Well, now it's time to say goodbye to all of our friends. MICKEYM. Remember the Mickey Mouse Club. Anyway, that probably seems silly, but okay. Now what I'll do is we're going to get rid of this, and now you'll see some of the working screens here. Next thing I'll do is I'm going to make sure you can see the telescope cam. So I'm going to do this, and there it is over there, and we'll bring it up a little bit. Now over here we are going to do a very important thing. We have to park the telescope, which gets it into the position where it will be. Just gonna get rid of this. Get into the position where it's going to be stopped, in a final resting spot for the night. Okay, and so we will hit the park button over here on our stuff right up there. You can see it says park right here. All right, I parked the telescope and watch on the screen, and you'll see the telescope move to a new location. Okay, that location, which you can now hear it moving. It's a little delayed.
People love that sound.
Yeah. Okay, and it stops there. Okay, and the telescope is now parked. And what we can do at this point is we can come over to our screen here, and we'll do this. First of all, we can get rid of this guy. We don't need it. And now, with the telescope parked, this can go away. All right. This is our telescope control system. And now, these are the commands that I've been issuing to the telescope during the course of the night. And what I'm going to do now is I'm going to tell the telescope power to shut off. And when I do that, if you look in the dome, you'll see that the dome is going to change to a little bit darker color. There it goes. That's the power being shut off now to the telescope. All right. And then I'm going to hit another key, which actually is the equivalent of closing the roof, which we don't have here. So that's not going to happen, but it does work anyway. All right. It's good to get in the habit of actually doing that, because once it's a roll-off roof, this is closing the roof. And it'll take about 10 seconds to close the roof. Okay. And now we just close the cover on the telescope. And now you'll see how that works right now. And there it goes. All right. Okay. And that's the sound it makes as it's closing. And the way I did that is there's a stepper motor that I put on here, and it's right there, and I programmed it to open with this special gear, and so we can tell it to open. All right, and you see it open, and then I can just add another thing to have it close right away. So there we go, and now it'll close. All right, so everything is now closed up, and the only thing that has to happen now is the dome has to be closed manually, because I did not do anything with the dome to automate that, because this dome is not able to be automated in a way that I think is robust. The shutters, the things that open and close here, like I said, they were blown off several times. That will never happen again. However, this is really an observatory that's meant for someone who's got a telescope they want to go out to and open and use. It's not meant for a telescope that is remote like this is going to be. Okay, so there it is. Telescope's all closed up, and this program here is now ready to be put away for the night. Everything else is ready to be put away for the night, and I can close up all the links now and get us back to do what we were doing. So there you go. Now, as we speak, the cloud is being populated by these files from the telescope. They are coming from the cloud down to this computer that I'm sitting at here, just like they will be, when we're out in Arizona. So there we go. So there's the closing of SkyTour LiveStream, and that's what will happen out west. Now, I wouldn't even have to go anywhere. Right now, I could just be done. Say, okay, put away the computer, shut it down, and go to bed if I wanted to. But now, because this is still a dome here that has that manual issue, I've got to go out and close the dome manually. Wouldn't have to do that normally, because I would have have it all set up to just be shut off and be done with it. So anyway, I hope you guys have had a good time tonight. I've enjoyed your company tremendously. You guys are amazing. I want to thank you for coming out and joining us. And Amanda, I want to thank you, as always, for coming in.
Oh, thank you.
Your invitation's always open. And Daryl says everything's better with Amanda. And he's right.
Thank you. I appreciate that.
For the most part. I'm kidding.
For the most part, yeah.
I'm kidding. Okay, guys. Well, thank you for
Everyone
coming
be
out.
well. Keep looking up.
Yeah, that's right. That's the
Where
line I
goes your
usually say.
cue?
Huh?
Keep looking up.
Yeah, that's right. And that's
What? That's your cue. What are you doing? You're not used to the roles being reversed.
Oh, except while you're driving?
As we come to the end of another SkyTour live stream, keep looking up.
Except while you're driving.
Ah.
Normally I say the keep looking up part, and she says the except while you're driving. So on SkyTour Radio.
He started off on the show saying keep looking up. I'm like, that's good in theory unless you're driving. So it just kind of stuck. But yeah, you guys shouldn't be driving out anywhere at this hour anyway.
That is true. That is
Lie
true.
out on your lawn and look at the sky or go to bed.
It's a little cold to be laying on any lawns right now. At least here.
Depending on where people are, yeah. Well, up in Canada it is. I'm not going. The
Yeah,
only
if you're
place
laying
I'm
on
lying
your
is in
lawn,
bed with my cat.
if you're laying on a lawn, then there's going to be an ambulance coming to get you because something's wrong.
Right.
All right. Hey, Monique Coleman. Thank you for coming out. I didn't see you come in before. And Canada Boy is here too. Thanks, man, for coming out.
Bobby?
Huh?
Bobby from out west. All us Canadians know each other.
Oh,
That's
okay.
Bobby.
Okay. All right. Very good. I'll remember that. Yeah. And thank you, Amanda Shaw, actually, as well, too. So, Rachel, thank you. All of you guys, thanks so much for coming. And PG, good night and have a good evening, folks. I will catch you on the other side of all this. And we'll be back on the next clear night. And that could be tomorrow. So, stay tuned. And if you're interested in seeing what we do with these files, do go to the Facebook page and look for the uploads of tonight's files that will be up there probably over the next day or two, because I do have to do processing on them, and I shall do that. It's 1 a.m. here in the East Coast of the United States, and it's going to be a long night because I'm going to be doing some processing before I go to bed. So you guys have a good night, and we'll talk to you later.
Night, everybody.